Hello, everyone. We'd like to welcome you through our GAIN webinar series in the regulatory area to today's session on establishing new routes to lead the way to deployment. Excuse me, this is the fourth in the series of four. So for those of you who are joining us for the first time, we welcome you this afternoon. And for those of you who've been with us in one or more of the first three, we appreciate you coming back to pick up some more information and provide us some insights as we move forward. Next slide, please. A couple of logistics before we get started. I'll cover the agenda in a moment, but just wanted to thank our industry representatives, experts in different parts of the overall industry structure and on these topical areas. They include Doug McDonald from GE Hitachi, Ross Moore from Oklo, Peter Hastings from Kairos Power, Mark Nickel from NEI, and Tom Bergman from NuScale Power. Again, a couple of logistic topics for today's session. Please be sure that your camera is turned off and your audio is muted as you're listening and participating. Another item that's not on the slide here that's helpful is if your organization allows it to occur, things work better on GoToWebinar if you're disconnected from the VPN system that your organization may use. So if that's an option, that's helpful. As we're working through today's session, we encourage you to ask questions or ask for clarifications. There's a questions field in the webinar similar to other systems, so you're welcome to use that. Again, either to ask questions about the session or if you're having any particular kinds of technical difficulties with audio, video, or being able to participate. I'll note to you that the webinar is being recorded and it'll be available on the GAIN website along with the presentations. And that same thing is true for all of the material from the first three webinars. So if you see a topic as we're going through our summary, or if there's something you'd like to dig into a bit more and weren't able to participate the first time around, you're welcome to access that material on the GAIN website. Next slide, please. Just a brief rundown of our agenda for today. I'm going to spend about 10 minutes quickly going through the highlights from the first three webinars. They basically describe what the existing regulatory framework and licensing structure are, and then I'll turn things over to our four industry presenters who will talk about their insights and perspectives and strategies as they're working their way through that process. And then near the end, our fifth industry participant, Tom Bergman from NuScale, will moderate a panel discussion and cover topics related to the presentations along with other topics of interest that are in this general arena. And again, the primary theme for today is how one might go about starting from the existing regulatory structure and moving that forward to a point where an advanced reactor technology has been successfully deployed and is operating. Next slide. I won't go through my bio in detail. I've been in the business for about 40 years, first 30 or so of that on the commercial side, in areas of system engineering and regulatory affairs. I've spent the last 10 or 12 years predominantly through the Idaho National Laboratory, working with the DOE and industry to knock down hurdles and work through regulatory and policy issues that are restraining advanced reactor technologies. Next slide. So when we started the overall webinar back around the Thanksgiving timeframe, the primary focus was to help all stakeholders get a very clear understanding of the existing regulatory framework for commercial reactors. And it was sort of along the lines of understanding the different parts of the framework, how those different parts fit together, and then maybe even more importantly, how they came to be what they are. And the whole focus there was to increase or improve industry understanding and insight so that as various stakeholders are building their plans and strategies, they can do that in a way where they clearly understand the uncertainties and risks that are out there, and those can be in a lot of different places, technical, financial, schedule, and consider those and find workable pathways to get through those issues and hurdles to work through a successful and efficient deployment strategy. Next slide. So in webinar number 1, we covered the period of time that was nominally from the mid-50s through the, I'll call it the early 80s. And it was the initial development of both nuclear energy as it moved from primarily moving weapons platforms around to a conversion into the commercial industry. And in parallel with that, the regulatory framework, many parts of which still exist today, were being developed at about the same time. So next slide. So back at that time, we spent a little bit of time talking about the shipping port reactor and how it was a translation of some technologies and some insights from the Navy's nuclear propulsion program. And at that time, again, there was a lot of interest in moving from smaller scale or limited application reactor types to larger scale demonstrations and then moving on to commercialization. So there were a lot of parallels at that time that are very similar to some of the same kinds of considerations and desires that we have in the industry present day. Next slide. During that initial first webinar, we talked about the 3 major bellwether areas, or the 3 major eras of regulatory framework development. So again, from the mid-50s through the mid-70s, the technology was being developed. There was a period of time in the very early 60s where the notion was that industry would be self-regulating, and then that shifted a bit into the Atomic Energy Commission and the Atomic Energy Agency being more directly involved. In the 74 timeframe, there was the split between DOE and the establishment of the NRC. And then during that period in the late 70s, the NRC was in the process of developing its rules and regulations, and then moved on with some corrections and some updates based on operating experience. If you remember, one of the key points we took away from that is during that period of time, there was a lot of dialogue between developers and regulators, but with owner-operators a little less involved. And the other point there was, as those rules were coming together and then the 3 Mile Island accident happened and additional rules and considerations were coming together, that we got sort of into a mode of industry asking NRC to just tell us what you want, because we can't spend a lot of time debating the rules. And again, that put us into a structure that's been very conservative and workable, but maybe is a different structure than what we might have developed otherwise. Next slide. Another key focus that we covered in that first webinar is that, again, based on dialogue with regulators and evaluation of regulations and regulatory requirements, we stressed the importance of understanding that the owner-operator is ultimately the holder of the license when a reactor technology is deployed, and is ultimately solely responsible for the safety of the reactor. They work very closely in partnership with their designers and developers to make sure that they are moving in the right direction and have a good structure for achieving that safe operation. Again, it's primarily and solely the responsibility of the owner-operator working with the developer and designer, and the NRC has an oversight or a confirmatory role that's done on more of a sampling basis in focused areas. So again, not to lose sight of the fact that the owner-operator is solely responsible. Next slide. Then going on to webinar number 2, we spent some time focusing on, so what's actually in the book? What actually is the regulatory framework? How can you go about interacting with NRC in addressing some of those issues and challenges? And what are the kinds of things you should consider when developing a deployment structure or strategy? Next slide. We spent a fair number of slides in that session connecting the U.S. Constitution and how it flows down through, again, the Atomic Energy Act down to the individual licensing requirements that exist today. And then some of their implementing guidance, which has a bit more flexibility but provides some insight based on past experience and past accepted practice. So we talked about that hierarchy and how all of those different document types connect through a regulatory document decoder ring, I guess I'll call it. Next slide. We spent a little bit of time working through all of the different parts of the NRC's organization, including the structure of the commission and the advisory committee on reactor safeguards and the ASLB and all of those various structures. But we primarily focused on making sure that you're clear on this area of nuclear reactor regulation, or the NRR portion of NRC. And the two boxes in the green there at the bottom are focused on the portions that aren't the whole ball of wax, but are the area that most advanced reactor developers would deal with primarily. One portion is the group that develops updated or clarified guidance and regulatory requirements, and the other portion is the group that actually reviews the license application. Next slide. And then we spent a little bit of time talking about key considerations and some of the major attributes for having an effective and efficient engagement with NRC on a license application. The example that we talked through was with the recent TVA experience in working through the Clinch River early site permit. And the primary message there that I don't think is a surprise for anyone, but the primary message there is to just clearly communicate what it is you're intending to do, have some focused and early dialogue with NRC on, again, those plans and where you may see issues and challenges. And that discussion also highlighted the opportunities and some of the advantages for having NRC audits of various material to help move things along. Next slide. So then in webinar number 3, which was about 6 weeks ago, we spent some time looking at various available pathways, movement of information within the process, and then Chris Nolan from Duke Power spent some time talking about regulatory processes and how Duke evaluates overall project risk. Next slide. So as far as the pathways, I think most folks are familiar that there's the Part 50, sometimes referred to as the two-step regulatory or licensing process with a construction permit and an operating license. And then the Part 52 approach, which is the design certification and combined license approach, sometimes referred to as the one-step process. We spent a fair amount of time talking about the differences and some of the major considerations there. At a very high level, the Part 50 process would allow the developer and owner-operator to potentially start work sooner with a little less detail being available. But the expense of that is that it has some additional hearing opportunities and some areas for challenge from the public that are a little later in the process. Part 52 has a much more stringent requirement up front for additional detail, but tends to mitigate some of that downstream hearing risk. So it's all a matter of establishing the right approach or right process for the project in mind. Next slide. We spent some time with the attorneys who were presenting on the topics of mandatory and contested hearings. I think in a lot of the dialogue these days, those parts of the process are understood to be out there in the future, but have been sometimes treated as a bit of a black box. So the purpose of this part of that webinar was to shine a light into the box there a little bit and to go through some of the specific details and some of the issues and challenges so that those are well understood and can be considered in picking the overall regulatory pathway. Next slide. And then finally, as I mentioned, we had a speaker from Duke who went through some considerations when evaluating overall project risk. They really fall into three areas. There are siting, technical or technology risks, and confirming whether the design you're looking at will actually work. And then there are the regulatory risks in bringing that to fruition and through the application or adaptation of the existing regulatory structure. I think a thing that was interesting that came out of that discussion is at least within that owner-operator's system, they see the siting risk as being about half of the total risk for a project. So again, I know in a lot of our dialogue, we tend to drill down on or focus on the technical and regulatory risks, but we just need to not lose sight of the fact that a big piece of the pie is associated with the siting piece. Next slide. So with that, I'd like to turn things over to our first speaker, Doug McDonald from GE Hitachi, and he'll talk a bit about the topic of leveraging past work into the future. Thank you, Doug.
Thank you, Jim. Next slide, please. And we won't spend too much time on the biography, but it will be in the presentation materials that are provided later. Suffice it to say, I've been with GE Hitachi for quite some number of years, going back to when we were just GE before we formed a global alliance with Hitachi. Next slide, please. Several pieces that the webinars went through, stepped through a lot of the history. So I'll spend a little bit of time on this slide, but really to give you the background towards the back end or the right-hand side of this, where GEH has been spending a lot of its times recently. It's certainly been involved in the nuclear field since its onset. At Vallecillos in California, we had AEC license number 1. We followed that up with demonstrations in Canada. We've had, in 1974, we had the 25th BWR, which is Peach Bottom 3, 50th and 86. And then now we're starting getting more into the area that we'll focus on in this presentation. A lot of the presentation will be on our light water, but we will cover some of the Gen 4 aspects as well. Right now we hold 2 DCDs, one for the ABWR and one for the ESBWR. And on the ABWR, it was granted in 1997, and we're currently undergoing the renewal process for that. The license was for 15 years. About 2 years before the anniversary, the 15th year anniversary, we started working with NRC to start the renewal process, and we're in the process of doing that, and it will close here almost any day now, but certainly within 2021 is when we'll finish wrapping up the renewal for another 15 years on that. In 2014, we had the ESBWR DCD. Again, very similar process, time had gone on, certainly more evolved and extensive than the DCD for the ABWR. This is a very similar time frame when Westinghouse received their DCD for the AP1000. So as both ourselves and Westinghouse went through that, there were a lot of similarities. And when we look at lessons learned within GH and how we apply them, we also do look at industry. So for example, when Westinghouse took their approach on perhaps not renewing immediately within the 15-year time frame, that certainly caught our attention on the ABWR, for example. As I mentioned to you, we're deep in the renewal process, so it certainly will be successful at it. We're at the end of it, but it's certainly more costly than expected to be. As we come close to the anniversary for the ESBWR in the 15th year, we will take that in consideration for the AP1000 experience as far as perhaps delaying the renewal process if that makes sense given the experience at that time. So not only do we learn lessons from inside, but outside as well. And then more recently, and part of the rest of this presentation will focus on, is on the BWRX 300. In 2019, we submitted our first licensing topic report on that. In addition to that, for the BWRX 300, we started the vendor design review in Canada. We started that in 2019. We expect to wrap up next year. Most of, like I said, the right-hand side of this is highlighted on our light water reactor, but we certainly have had our liquid metal reactor, the PRISM reactor, and now working with Natrium for with TerraPower for the Natrium reactor. We've been working on sodium-cooled reactors for about 40 years now. Our first introduction from a licensing basis is in 1987, we submitted to the NRC as part of the Advanced Light Water Metal Reactor Program, a preliminary safety information document, not a safety evaluation, but an information document, to really sort of test the waters of how the NRC might evaluate a Gen 4 reactor. And in 1994, the NRC responded back with a conclusion in the pre-application safety evaluation report with the conclusion that there was no obvious impediments to licensing. So again, we continued that to follow on. We've been heavily involved in the licensing modernization program, in the TCAP Act portion after that. And really all of the things that we're doing in the light water and the liquid metal have this common theme of late. It's really how do we get to a risk-informed, performance-based regulatory framework. We see this, the key aspect of that is first simplicity and transparency, to which any licensing can be simple. But more importantly, how do we really evaluate the necessary structures, systems, and components and make sure that they have the proper safety classification, with an overall goal of having a minimum number that are safety class 1, or safety related, if you will, classification, and only having that small subset that is truly necessary to be in that highest safety class. And we believe the framework that we've applied for the BWRX 300, which is different but similar to the license modernization program, is a very robust structure for which to accomplish that. On our liquid metal side, we're part of the versatile test reactor. The PRISM reactor will be used as a heart for that, heart of the versatile test reactor. And the DOE interaction for certifying also looks at a risk-informed, performance-based approach with the NRC observing. So hopefully we'll get some good synergies in that aspect. And then really as we look at Natrium, which is being led by TerraPower and being demonstrated part of the ARDP program, do plan to utilize a Part 50, again, with a twist on it for risk-informed and performance-based. So again, common themes here. How do we really simplify the licensing? How do we make it more transparent? And more importantly, how do we reduce risk and cost of implementation of the nuclear reactors going forward? Next slide, please. And then really that aspect of reducing the cost and the risk is what drove us in our light water space for the BWRX 300. It is an evolution of many things we've done in the past. It's our 10th generation boiling water reactor. It leverages quite heavily on the ESBWR, but there's a few key pieces that differentiate it from the ESBWR, especially around how it handles LOCAs, loss of coolant accidents. In prior designs, we had a lot of safety systems designed to reduce pressure to either high pressure injection, low pressure injection, and all the cost, water, space associated with that. In the BWRX 300, we've taken a inventory conservation approach, which we'll talk about a little bit, but not too much for this presentation. We can talk about that elsewhere. But it does really look at the licensing aspects and making sure, again, this safety assessment framework to make sure we have the proper design, proper classification for all the systems to approach to do that. Really wrapped into that concept is the design to cost approach, making sure that we achieve a significant cost reduction per megawatt to be cost competitive. You know, perhaps if we look at it, we need a safe reactor. We also have to have reactors that can be deployed. We have to have a good balance between the two to make sure that we're meeting our objectives of reducing carbon while also meeting our most important safety objectives. We do have world-class safety incorporated with it, load falling, not particularly relevant in today's discussion, but important to our customers. Also, we've taken a look at the way the constructability is integrated into design. One of the pieces we learned from the ESBWR is it had a significant amount of construction required for the DCD, construction details required for the DCD. I'll give you an example. We had drawings in the DCD that showed the rebar layout for various parts of the reactor building. And as we went to a high frequency site for high seismic demand site, we actually had to add one piece of rebar in a layer that was already existing of rebar. Took the licensing change request to make that go through. And so it's all that complication around that, which, as we'll talk about in a few more minutes, drove us to a Part 50 application for the BWRX 300. Like I mentioned, we have discussed with the Canadian regulator in the form of a vendor design review, which we started, finishing up next year, and then also with US NRC doing license copper reports to minimize risk for it. We're right now in a down selection process in Canada with OPG. If that goes well for us, then we'll be operational to the BWRX 300 in 2028 for the first unit, and then many more to follow after that. Next slide, please. Again, getting back to why do we care about the licensing aspects as it relates to simplicity? Simplicity drives cost reduction, but if you don't have a licensing mechanism to enable that, to go hand in hand with that, you won't get to what you're needing to. Again, this slide, I won't spend much time on it, but it shows the simplification from the ESBWR, which is a Gen 3 Plus reactor with passive safety systems, already relatively simple compared to the existing fleet. But with the change, the way we mitigate LOCO with what we call the integral isolation valves, we're able to minimize the amount of structures and components even more while still maintaining world-class safety with the proper framework for regulatory and safety aspect that goes with it. Overall, what we've been able to achieve with BWRX 300 is reducing the building volume, including concrete, on a per megawatt basis by about 50% compared to the ESBWR. And so that gets us into that cost targets we need to meet for deployment. Next slide, please. For the BWRX 300, to minimize both deployment risk as well as licensing risk, many areas are using proven technology. And so, for example, in the fuel, we're using the exact same fuel that's in the fleet today. And so the licensing risk around fuel for the BWRX 300 is effectively zero in the US and minimized in other countries such as Canada and throughout Europe, where BWRX 300, the same fuel, GF2, is deployed in Europe already. For the RPV, the steam conditioning components, the separator and dryer, are already very similar to what's in use in the industry today. The thermal hydraulics, which go on in the nuclear transport system and steam transport systems, are the same as existing reactors. And control rod drives are basically the same as we're using for the ABWR, which have been deployed and tested already. Again, the proven components, prior testing that we can leverage, all allow us to a relatively quick and licensing terms aspects getting the BWRX 300 licensed. Next slide, please. One of the other key aspects that we approached the BWRX 300 with was how do we simplify, how do we get a little bit more global in our approach? We had a generic design assessment for the ABWR that was performed in the UK. It was based on operation experience with ABWR in Japan, licensing and build in Taiwan, not operated in Taiwan, and then licensing in the US also. But even with all that wealth of information, it was very expensive, 4 years process, several $100 million to actually get the GDA in the UK. But what we did learn is, as we took an approach, if we based it on an IEA approach, we could map that back into US NRC without too much difficulty, and then to other regulatory regimes in Europe, Middle East, South Africa, other parts of the world. It was a relatively easy mapping from an IEA basis, as opposed to what we've previously been doing is working on the US basis and then converting it to the local regimes. Really basing it on a defense in depth process and the IEA guidelines around that really gave us a lot of flexibility. And we've been proving that out as not only we're advancing in the US, but in Canada, which typically follows IEA. So this has been proven a good path for us to follow, and we're pleased with the results we've received so far on it. Next slide, please. Sort of summarizing what we're doing with the BWRX 300 in the US from a licensing approach. As I mentioned, it has a lot of similarities to the ESBWR, certainly from a testing basis, the analytical methods which we use to analyze natural circulation, the transients are very similar to the BWRX 300. And so be able to take those and apply them very easily to the BWRX 300. And also the fundamental operating characteristics are very similar between the two. They really differ in how they mitigate accidents. And for that, we've done the licensing topic reports to reduce the risk on licensing. So again, I've mentioned a little bit, the RPV isolation valve allows us a different methodology to deal with loss of coolant accidents. And this particularly allows us for the BWRX 300 to effectively bottle up the RPV, if you will, and use isolation condensers to remove heat after an event, whatever that event may be, from the containment and maintain coolant inventory, because the IC, isolation condenser, takes the steam from the reactor, condenses it, and then returns it back to the reactor. And so it's a coolant conservation versus a situation where in most reactors today and in the ESBWR, we allowed the inventory to escape from the RPV. And in many cases, we opened up the RPV even more to get it to low pressures to allow more safety systems to inject. And so that resulted in larger containments, more systems, and much more water in the case of the ESBWR compared to the BWRX-300. And so what we did on one of the first steps in licensing for the BWRX-300 was to introduce this top report with US NRC. And as of the end of last year, they did issue the final safety evaluation report. And now there's just a few administrative pieces gone with that, and we're effectively done with that particular licensing risk for the BWRX-300 with US NRC. Other ones we have in process or effectively finished, we have the SERs issued on, are on the containment performance. Boiling water reactors, you probably think wet wells, suppression containments. BWRX-300 is a dry containment. And so we had a license talk report about that topic. We had the SER on that, was issued in January. Reactivity control, we're challenging the way, do we need a safety-related boron injection system? With this license talk report, we made the case we did not, and that was approved in January this year. We also have the way and methods which we're evaluating the containment. As I mentioned, it's a dry containment. The methodology we're using to evaluate that dry containment is similar to PWRs. We did see that as a risk, and we've undertaken the license and top report of that, and the RAIs are underway for that particular portion. The advanced civil construction that we're using is different than the existing reactors, and so we're using a much more cost-effective style of construction to sink a shaft, if you will, and then the building within that shaft for our safety-related structure, which in the case of BWRX-300 is only the reactor building. The NRC has accepted it and are currently reviewing that, and we expect that to conclude before the end of this year as well. And going back to sort of one bullet point before, one of the regulatory risk abatement features we have for the BWRX-300 is the use of existing fuel. With that, we still believe it is appropriate to use Part 50. We look at the overall risk, benefits, the direction the industry tends to be heading, lessons learned from AP1000, lessons learned that we had from the combined operating licenses that have been issued for the ESBWR. The amount of change control that's required before building everything starts is, in our opinion, onerous, adds a lot of risk to the projects. And so certainly as we look forward to the next steps, how would we deploy the next units, working with multiple of our potential customers, Part 50 seeing the overall least and lowest risk profile, and that is the manner in which we're proceeding. Also happens to match very well what is Canada tends to do. They have a two-step process also where they do a license to construct and then a license to operate, very similar to the construction permit application and operating license in the United States. As we get more units deployed, we'll certainly look at using Part 52 in the future, depending on exactly how many pieces are being deployed in Japan, excuse me, in the United States, and the frequency of them. Next slide, please. Did want to touch briefly on the international markets. We have excitement here in the US, which we haven't seen in quite some time. The strength of that interest, the commitments to zero carbon or carbon neutral that many companies have, seem to make it more viable than perhaps during what we'd call the Renaissance. But there's even stronger interest internationally. How do they really achieve their carbon goals? Not only are they looking for first deployments, they're truly looking for fleets in the mid to late 2030s. Europe has a carbon tax in many of the countries. It is driving the industrial users in those countries to look for alternatives, really to push, and their solutions coming up with for sustainable, deployable, carbon-free energy is more and more frequently nuclear energy. And we're seeing a lot of interest there. From a perspective of a vendor, we have a huge desire to drive for commonality. The check marks are the ones that seem to be working well already. ASME Section 3, widely accepted by most of the countries we want to do business in. It makes it easy to take the RPV designs and replicate them country to country. Very simple, same codes being applied. IEC versus IEEE. Again, most countries outside of the United States accept IEC. The NRC tends to be accepting to that. We're certainly considering putting a licensed and topical in front of them to make that more solidified. But we see interest in doing that with the IEC and using that as the standard for which we designed the BWRX 300. I should have put in here ANSI AISC N690 for the use of steel composite structures. Again, it's accepted here in the United States. NRC has accepted it, and several European countries have accepted it. And so that's certainly another code that allows commonality out there. Regulators are starting to work together. There's a lot more work to be done here, but certainly the NRC, CNSC in Canada, ONR in UK do have agreements in place, either on a tri-party basis or bilateral, with which they are working together. We do have some examples of where NRC and CNSC are working on reviewing common aspects, but it is not widespread yet. There are certainly still some examples of where we have commissioners saying, we may never get there, and perhaps we won't, but from a vendor perspective, from an owner's perspective, the more and more progress we can make there, each step we make is a step in the right direction, in our opinion. As we get sort of more into the circles versus the checks, how can we achieve a standard safety assessment framework? Perhaps, probably, using the IAEA guidelines, that would be our recommendation. How could we get acceptance from all regulators, including the NRC, to go in that manner? And then sort of the holy grail that we've all sort of considered is how do we get standardized license submittals and approvals, where that all the countries can come together, have the proper say, get it licensed and then deployed on individual countries, and then side-by-side specific aspects that they need to take care of, but have a more transportable and generic licensing. We may not get there, but as we make more and more approach to that, it will certainly make deploying nuclear in the numbers that we need to make a difference in greenhouse gases more likely. With that, that concludes my prepared statements. There may be a couple minutes here for Q&A.
Thanks very much, Doug. Hey, I wanted to pass along one question that came from the audience. And before we do that, I did want to remind folks that we've arranged on the agenda about 5 minutes at the end of each speaker's time to address any questions you might have. So if you could send those to us as they're speaking, we would appreciate that. The one question that we got in this area, Doug, was on the topic of siting. I think at the end of my lead in, I mentioned that siting is sometimes a bigger percentage of the risk than might immediately be obvious. At least in webinar number 3, the industry presenter mentioned that the two key things there are: you first have to find a site or a piece of property that aligns with what you're trying to do with the machine and the end users that are the target or are the customers. So it's a geography thing. And then the other big piece is associated with the level of acceptance there is in the local community to the extent that's needed. So that was the theme. I just thought I'd pass those pieces along since I don't think you were in on webinar 3. But yep, with that as background, can you share any additional thoughts or insights you might have from GE's perspective as you're working with your owner operator customers?
There's a variety of things. Certainly the local acceptance is to a broad extent, at least in initial phases, outside of our control. But as far as how does it fit in each individual site, we've been doing this for quite some time, and so we have, for example, seismic profiles which cover 80-90% of what we'd expect people to put nuclear reactors in the United States, and we have multiple profiles, different frequencies that we analyze our base design to. Same with soil profiles, whether it be soft soil, hard soil, or medium soil, or a rock site. We do multi-dimensional analyses on those to make sure that it is applicable. The standard design can handle the various loads at various sites and the soil conditions that we find. Now, given that, each site does present its own different challenges. So whether it seems like invariably we'll have seismic challenges that, for example, the North Anna 3, during the process of getting their COLA, they had another mineral earthquake, which reset the seismic expectations for the eastern seaboard. And so we had to go back and redo that. And now that is part of our standard seismic profile to make sure that we do include that. And so we certainly try to do those pieces as we reach out to more and more groups, industries, adjacencies. for education. That also helps a little bit in that area too. That I'm sure there's more we can do there, but until it gets to more a site-specific sort of more technology, we have a little bit of a the chicken and the egg. How much do we put out for many sites versus focusing on specific sites that we have contracts for?
Okay, thanks very much. I appreciate that. I'd like to move on to our next speaker, but I will mention if there are additional questions or you'd like to have additional dialogue on the topic of siting, I'm sure we can work that into the panel session at the end. So now I'll turn things over to Ross Moore from Oklo. And again, if you have questions as Ross is speaking, feel free to pass those along through the question option on the webinar, and we'll work to get to them at the end. Thanks.
Thank you, Jim. And I'll just do a quick sound check, make sure you can hear me.
Yes, I can hear you.
Thank you. I'll just start by saying, I'm very excited to be here to chat on, specifically my presentation is focused on some of the things that we've done with Oklo and our COLA application that's currently under review by the NRC. So I'm going to talk about that. I'm also going to talk about some of the, specific vehicles that we see, or the methodologies that we chose to employ for the Aurora INL COLA, and how we see that both as beneficial to us in terms of providing simplicity and flexibility in establishing an application, but also potentially could be beneficial to other reactor designers as more and more designers are looking to, create and develop advanced reactors to meet, both the nation and the world's, carbon emission reduction goals. I'm grateful to the GAIN team here and all that they've done setting these webinars up. I think this is a great opportunity for many folks to learn a little bit more about the regulatory process here in the U.S. And what those challenges might look like as folks continue to look forward to navigating these processes. I'm also here with a phenomenal team of presenters, so I'm very grateful to be a part of this webinar. Next slide. So a quick background for myself. I'm Ross Moore, the Director of Regulatory Affairs here at Oklo. I joined Oklo back in September of last year, September 2020. Prior to joining Oklo, I was a licensed senior reactor operator at Salem Nuclear Power Plants 1 and 2, providing oversight for control room and field activities and generally managing risk on a day-to-day basis. And before that, I actually spent roughly 7 years at the Nuclear Regulatory Commission. I provided a variety of roles from supporting operating reactor license renewal activities to supporting regulatory framework development for advanced reactor design reviews, and then I also supported on-site inspections for the operating fleet. So next slide. To give a quick introduction, I'd like to start with what Oklo is trying to do, right? So we specifically are looking to develop clean energy products, in this case the Aurora design, to help mitigate the social and environmental impacts of pollution, as well as energy poverty, essentially providing energy to remote locations or developing nations, through our designs. We submitted our combined license application in March of 2020, and it's the first ever advanced fission combined license application, and it was accepted by the NRC almost a year ago today. It's different in a number of different ways because we recognize that we presented a very different advanced reactor technology up for licensing review, and so we believed that it needed a new approach to licensing, and so that's part of what I'll describe here today. Next slide. Just real quickly, for those who may be unfamiliar with the Aurora design, it's roughly a 4 megawatt thermal reactor, 1.5 megawatts electric. It uses metallic fuel. One of the unique aspects of the Aurora design is it uses heat pipes as a mechanism for heat transport, and that allows us actually to really take advantage of being able to site in a number of different areas. We don't rely on a large water source, so we don't need to be near a river or a lake like many of the large light water reactor fleet does. The capacity factor we anticipate being greater than 90%. We are licensing it for 20 years. We did not license it with any intent to refuel. Essentially, it can operate for 20 years without refueling. And the actual land footprint is very small. So next slide. The applications, I think I talked a little bit about them, but the size and flexibility in terms of where we site allows us to really provide energy resource to a number of different areas, off-grid remote communities I mentioned, industrial facilities, mining, resource extraction, and the full list there. So we're really excited about what we can do with this technology and how we can use it to push nuclear and the benefits of nuclear out, beyond, the traditional uses. Next slide. Here, real briefly, I think, much of the regulatory challenge has been presented in prior webinars, but essentially, the rules, the requirements established in parts 50 and 52, as well as the corresponding guidance for implementation, are really predicated on the current existing fleet, decades of large light water reactor experience. And as a result, some of the prescriptive requirements and the enhanced guidance over the years has resulted in, significantly increase in cost and licensing burden, or licensing cost and burden. So it challenges the advanced reactor fleet, and especially very small plants, from really being able to get their foot in the door and get licensed efficiently and effectively. So that's part of the challenge, as well as the enhanced reliance on probabilistic risk assessment or risk analysis. Essentially, there's not the thousands of reactor years of data for advanced fission, even though many, advanced reactors can rely on, decades of advanced fission experience. It doesn't have quite the extent of operating experience that the large light water reactor fleets has. Next slide. So what we tried to do with Aurora, recognizing that many of the guidance documents available, to support licensing are framed around the current light water reactor fleet, is we went back to the requirements themselves. Really, what do the requirements ask? And so we built our COLA structure around what those requirements are, and our application content around that. And that essentially allowed us to kind of work directly through the requirements, and establish our safety basis along those lines. Next slide. This is really just, so the next few slides I'll be discussing, a little bit more about the application content. Next slide. So I highlighted on the previous slide, the requirements for COLA are outlined in parts 5277, 79, and 5280. The Aurora COLA essentially follows the structure of these requirements. It allows us to really directly tie what the requirements are to how we meet those requirements in the COLA, and so that it makes it a very clear and direct commitment to what those requirements are and how we're meeting those requirements. Essentially, then when we evaluated them, we essentially looked at the requirements, recognizing that many of these requirements were also predicated upon light water reactor technologies. So we evaluated them. We kind of did an internal analysis as to whether those requirements were applicable to the Aurora design, and if it did apply, but it wasn't necessary for the Aurora design, then we would submit an exemption. And if it did not apply, then we established it and justified it as a non-applicability, submitting that in a separate enclosure with the application. Next slide. So here is highlighted the key parts of the COLA. At a high level, it follows traditional COLA inclusions, but it does include such things as the non-applicabilities requested exemptions section, which is the part I detailed before. So next slide. So in summary, what we found is we did actually pilot this application structure as part of an LMP pilot early in 2018, and we received that feedback, and that allowed us to ultimately submit our first combined license application, and it was accepted for review in June of 2020. It allowed us to streamline, exactly what the application and content needed to include. We resulted in an entire application with under 1,000 pages. We were able to prepare this application at extremely reduced cost, less than $10 million, from essentially design, birth to, COLA acceptance. And we're really proud of the fact that, we were able to come through with a streamlined structure, and ultimately we see that as potentially being beneficial in the future for, both our applications as well as future applications. So next steps, I'll talk to them briefly. Next slide. So as I mentioned, we submitted the COLA in March of 2020. It was accepted in June of 2020. And so the next part is we're in a two-step review. We're currently in step one, and we expect the two-step review to be completed in June of 2023. Next slide. So the two-step review process, it's a little unique to the Aurora application. Essentially what the staff recognized through the acceptance review is that we needed to align on the specific methodologies employed in the Aurora INL COLA. And that focused on the maximum credible accident methodology, the SSC classification, the role of quality assurance, and as well as the specific non-applicabilities identified, by Oklo that we presented in the COLA. After considerable engagement with the staff, we realized that the best way to kind of highlight those methodologies and how Oklo developed and created those methodologies is to separate those methodologies out into two topical reports. So essentially, we have the maximum credible accident methodology as well as the performance-based licensing methodology documents that we're essentially in the process of preparing now to help complement understanding of the areas in 1 through 3. Recognizing that the NRC staff has provided a letter on the non-applicabilities portion already to us last November. So we're essentially looking to resolve some of these outstanding items in steps 1 through 3. And SSC classification and QA are essentially tied in the way that they were implemented in our COLA. So we loop those up into the performance-based licensing methodology and explain that in that topical report. So next slide. So this is essentially the next several slides. I'll really dive into a little bit more detail in terms of what we're trying to do with the maximum credible accident as well as performance-based licensing to kind of really focus on a more streamlined approach, a simpler, more flexible way that one can get licensed by, leveraging programmatic controls to ensure, that key design assumptions are maintained, throughout plant operation. Next slide. So at a high level, we use this methodology overview. It's an iterative process. So essentially, we start with the design. We perform a safety analysis, steady state and transient, to kind of understand our design a little bit better. We apply risk insights. We do apply risk insights differently than maybe many reactors do. We essentially use a deterministic approach primarily, and then we leverage, risk analysis to kind of in a confirmatory role to validate that, the results we received from our deterministic analysis are what we expected. And then we kind of loop back and we may make design changes, based on what we received through those analysis, because the ultimate goal is to come down to the simplest design, one that, relies on as few safety components as possible. So, we establish key goals in advance of what we want our design to do, and that helps frame the overall analysis. We take advantage of, all the operating experience that currently exists. We might use, historical event types from non-LWRs. We looked at, the event categories established in New Reg 800. We look at the large light water reactor fleet for areas where, certain failures might be applicable to our design. We roll that out into our design analysis, and then we essentially establish key parameters, which are called design bases. These design bases are what ultimately, establish the underlying, safety considerations that our design must eventually establish programmatic controls to ensure. So we do that by establishing design bases and then tying those to design commitments, and then teeing up key programmatic controls to ensure that the operating reactor will operate as expected and as designed. Next slide. So the maximum credible accident methodology, Oklo is not the first reactor designer to take advantage of to use the maximum credible accident methodology. It's been discussed, for over 70 years. Essentially, it establishes the worst possible accident that can possibly occur to your reactor, and then it's, you bound the design based on that. And as I mentioned before, we perform a broad review of potential event initiators to determine what that maximum credible accident could be or could look like. As I mentioned before, we rely heavily on, worst case deterministic analysis, and that allows us to remove these uncertainties that, might be present in a risk analysis, especially for a first of a kind reactor. And then, that allows us to create ultimately a very conservative design, and, allows us to establish such things as, for the Aurora design, we set the EPZ at the site boundary. And in particular, for our smaller design, we can take advantage of, or we believe that the licensing approach can seek to align with some of those regulations that are typically employed for non-power reactors. Next slide. So then we get to performance-based licensing, and I want to make sure that it's clear that we kind of work the maximum credible accident as well as the performance-based licensing approaches. They're kind of in parallel. We employ our safety analysis, and then we use that to inform how our performance-based licensing methodology is implemented, and then we make decisions to go back to the maximum credible accident methodology and revisit it based on, perhaps we may make design changes that ultimately remove event categories if we feel like that's, that's important for our design, or otherwise, and it may change how the MC approach is employed. And then they feed off each other and iterate until we ultimately end up with, our end result. But the performance-based licensing approach is really to establish clear commitments that uphold the characteristics of the system, specifically those that have importance to safety. We do use performance-based licensing. We use our performance-based approach, can incorporate, items of the plant that are not necessarily relied upon for safe operation, but for the licensing component, we focus on those key design assumptions that are important for safe operation of the facility. And that allows us to, to scope licensing actions that, to include the information required specifically to evaluate the sufficiency of those commitments, and essentially avoid, requiring to submit with our application those items that are not or may not have an effect on safety. We then tie those commitments to specific programmatic controls. So we clearly try to determine those key design functions or design characteristics that are necessary, and then we strategize that down to programmatic controls, be it a pre-operational test, a startup test, a tech spec, surveillance requirement, essentially to ensure that through key milestones, key operational milestones, that we are continuing to demonstrate the safety of the plant. The other, portion of this is that when this is under review, we recognize that these programmatic controls then establish, regulatory controls, essentially opportunities for, the NRC to kind of look at our design, determine where areas of our design, may require additional consideration that may lead to new design commitments or new programmatic controls, and ultimately feeding into a final product with a comprehensive set of program controls that both we can rely on as well as the NRC can rely on, that show how Oklo is meeting our design assumptions and operating safely. Next slide. So this is kind of the general structure of how we outline our regulatory controls. I mentioned the design bases. These are the key characteristics of the system that ensure that the reactor is operating safely. And then we bring those down to specific commitments that allow us to demonstrate how that design basis is met. And then those feed into specific administrative controls to ensure the design commitments themselves are also met. So we do that through pre-operational tests, startup tests. It might be ITAC, or it could be tech specs and their corresponding surveillances, or the QA program itself. Next slide. So I think this is my wrap-up slide. I mentioned before, we're proud of the fact that we submitted the first ever advanced fission combined license application, focusing specifically on those requirements necessary to demonstrate you've prepared a safe design, as well as for a streamlined application. We assure safety in a more holistic, integrated methodology, and those are the methodologies I discussed. And it establishes specific regulatory control performance goals that allow for ensuring the design bases are met, but also establishing greater flexibility in how an applicant could potentially determine what those design bases and corresponding programmatic controls might look like. And then the last item here is that, we will be submitting these topical reports as non-proprietary. Part of that is, in part, we expect that it could be used by any reactor designer, but we also recognize that it also establishes a key design methodology that could be, that doesn't specifically focus on the risk analysis portion, or the PRA portion rather, of a design, and can really be focused on, the determinant. It can rely heavily on the deterministic construct, and then use PRA as a confirmatory mechanism to validate the safety of the design. So with that, I will turn it back over to Jim for any questions that we might have.
Hey, Ross, I appreciate the information and the insight. We have a number of questions. I'll pass along just two of them to you now, and then I'll let you look over the others, and maybe we can come back around to those during the panel session. The two that I wanted to cover now, so again, to keep us on track, on schedule here, is the first is in your presentation, you mentioned that one of the areas that Oklo is interested in are the off-grid applications. Could you give a sense for where those are in the U.S., if there's a lower 48 market for that, or if that's primarily an Alaska market? That was the gist of the question.
Yeah, I mean, I think off-grid could really be in a variety of areas where generally there are a number of communities. I think you specifically mentioned Alaska. You know, that's an example, right, where, you know, there are communities that rely heavily on diesel generators to supply power for their communities. But it's not just in Alaska, right? There are a number of communities that also rely, use off-grid power to support, you know, to support power for their community. It could also, I think I mentioned earlier, right, in developing communities, right, that may not have an established grid, right? It could be used to kind of establish a more microgrid or smaller grid or off-grid mechanism to help with energy poverty. So.
Okay. Another question was sort of a process-based question. There was some interest in, as you were starting your dialogue with NRC and establishing an engagement plan or an application schedule, there was some interest in how long that process took, you know, as you were working toward submitting your application and getting a review schedule.
So I don't know if this is specifically referring to pre-application. So we did have a little bit of pre-application engagement, but we generally focused our efforts towards establishing the license application. You know, I think the heaviest portion of our pre-application engagement might have been through, you know, and it really wasn't for us. We were trying to demonstrate some of the licensing and modernization project, you know, plans at the time, and so we kind of piloted our application through that, and that gave us insight into our application structure and content. But ultimately, we leaned heavily into our engagement by just submitting our application and working through that process. I'll note that we've, in our interactions with the staff, you know, over the last year, as we've submitted our application and gone through an acceptance review and kind of navigated the step one process, you know, we feel like the staff has been very supportive of the approaches that we've taken. They've you know, looked to work with the methodologies that we approached. They recognize that much of the guidance is, you know, potentially outdated for a design like the Aurora, and so we are seeing that through our engagement.
Okay, thank you. The other thing I'll mention, Ross, is there are a handful of questions that are all around the theme of the maximum credible accident approach and how that may translate, or how that may be different from, for instance, the LMP approach that maybe some others are pursuing. I think what we'll do is I'll let you look through those questions in a little more detail, and then we can likely come back around to that general topic when we come back around to the panel session, if that works for you.
Sure, that sounds great, Jim.
Okay, so I'll turn it over now to Peter Hastings from Kairos Power. And again, feel free to keep your questions coming our way as the speakers are moving through their material.
Thanks, Jim. Good afternoon, and thanks for the opportunity to speak with you today. I'm Peter Hastings. I'm Vice President of Regulatory Affairs for Kairos Power. My team within Kairos is responsible for NRC licensing, quality assurance, reliability engineering, and government affairs. Like several others here, I've been in nuclear for about 40 years, the last 3 years of which have been with Kairos Power. I've done work with regulatory framework for advanced reactors, light water SMRs, fuel fabrication, and high-level waste disposal. Next. Kairos Power is a mission-driven company, and we keep that mission in front of us in literally everything we do. That mission, which is to enable the world's transition to clean energy with the ultimate goal of dramatically improving people's quality of life while protecting the environment, will only be possible if we think differently about nuclear and prioritize our efforts to produce a technology that's not only safe, but also affordable. Next. Kairos Power recently celebrated its 4th anniversary, emerging from a DOE-sponsored integrated research project. Our co-founders, who all three participated in that project, concluded the next logical step was to establish a private company to commercialize the fluoride salt-cooled high-temperature reactor. In the brief time since its founding, Kairos has grown to over 170 employees, almost all of whom are focused on the technical side of the project. We're based in Alameda, California, in a repurposed World War II era hangar on the former Alameda Naval Air Station, a photo of which is shown on this slide. The lower photo was taken at our recent 4-year anniversary event, obviously held remotely. We're privately funded, we're singularly focused and fully committed to design, license, and demonstrate this technology through an iterative development and demonstration program. Our schedule is to deploy a commercial reactor before 2030 with a significant ramp up in deployment shortly thereafter. Next slide. As I said, our headquarters is in Alameda, and that's where the majority of our employees work currently. The converted hangar houses 50,000 square feet of office and lab space. I run the Charlotte office, which focuses primarily on licensing work, and we've opened and have begun work on a new facility in Albuquerque, New Mexico, that will house a component testing facility and an engineering test unit. We have a strategic collaboration with Materion, who's the preeminent provider worldwide of beryllium in Elmore, Ohio. And our most recent addition is the Hermes site in Oak Ridge, Tennessee. Kairos is an ancient Greek term for the right or opportune moment. And for us, that moment is the upcoming retirement of a dramatic amount of natural gas fuel generating assets. We believe this will drive a huge demand, and with the urgent need for non-carbon emitting technology, we believe we can help meet that demand. Of course, as I said, this will require we think differently so that we can in fact be cost competitive with natural gas. Next slide. Our progress has been remarkable, particularly in the last year during a global pandemic, and it reflects our iterative approach to development. The R-Lab, or Rapid Lab, was commissioned in Alameda over a year ago and supports parallel design with real-time prototype testing. The S-Lab, or Salt Lab, which is also in Alameda, enables testing with actual molten salt and is also now operational. The T facility, or component test facility, was sited in Albuquerque, New Mexico, and under very careful pandemic protocols, we're currently outfitting the existing building and have completed the building shell on a new co-located engineering test unit, which will be a reduced scale, non-nuclear version of our reactor for integrated testing. Late last year, we made the decision formally to include a low power demonstration reactor in our development strategy, and very quickly thereafter moved to acquire a site on the East Tennessee Technology Park for the deployment of that reactor, which we call Hermes. And right about the time we went public with that plan, we were notified that we had won an Advanced Reactor Demonstration Project, or ARDP, Risk Reduction Award, reflecting DOE's confidence in our ability to move our technology forward and to do what we say we'll do. We've been very active in pre-application engagement with the NRC staff, which I'll talk about more in a moment. And we very recently announced a cooperative development agreement with Tennessee Valley Authority, whereby they will provide design, licensing, and operations expertise to us as part of our design development. Next slide. Our development program is shown on this slide. As we sit here today, we're well into the design of the engineering test unit, which is a reduced scale non-nuclear test bed co-located with the T facility, or component test facility, in Albuquerque. And we're working very hard on the Hermes reactor design. Our original plan was to evolve through the test facilities that I spoke about earlier, the R-Lab, S-Lab, T-Lab, or T facility, excuse me, followed by the U facility, which is a full-scale non-nuclear copy of our commercial plan, and then go directly to a commercial scale demonstration reactor. But as I mentioned last year, we identified an opportunity to reduce our programmatic risk even further, and that the best way to do that was to deploy a reduced size demonstration reactor as part of our development cycle. You'll notice, as I mentioned previously, the iterative cycle approach we've taken to risk reduction. Also notice that it continues beyond the initial RSTU test beds and through deployment of actual entire physical plants. Next slide. Here's another way we like to visualize how our approach reduces overall program risk. Each stage of our deployment reduces that risk in various ways. The risks generally fall into three categories. There are technical risks, which are reduced by way of iterative lab scale testing that's closely integrated with the design, by way of deployment of the engineering test unit, and by way of deployment of a low power demonstration reactor that will show that Kairos is capable of producing cost-effective nuclear heat. Regulatory risk is retired by way of comprehensive engagement with the NRC staff in advance of the actual license application, which is an area where we think we're actually leading the industry. And then commercial risk is retired through demonstration of the actual cost and effort to construct a full-scale nuclear island via the non-nuclear U facility. Next. So what does the driver's seat look like? That's the theme of this presentation. Next slide. Admittedly, licensing the plant is only the first of many stops to reliable carbon-free electricity, but let's plot the route for at least that first part. Next slide. Your licensing strategy is informed first by your business case. Are you a power reactor? Are you a small modular reactor, a micro reactor, a non-power reactor, light water, non-light water? And how far along is your design at the time that you want to begin the licensing process? Next. What does the regulatory environment look like for you? How much do your investors value upfront risk retirement? And do you have the funding available to support pre-application engagement in parallel with design and development? Do you need exceptions to regulatory guidance or even exemptions from the rule, particularly in the near term for non-light water reactors? Do you need different principal design criteria? Do you need a gap analysis? The list goes on and on. Next. Maybe your first potential speed trap is identification of the need for a policy change or changes to the regulations. Be mindful that this can take sometimes quite a lot of time. Next. So given all this, what is your regulatory strategy? Do you plan a Part 50 two-step approach? Do you plan a one-step Part 52 approach? Do you even wait for the new Part 53? And what regulatory guidance do you use? As others have said, a lot of the regulatory guidance that exists today is for light water power reactors. So to the extent that you're stepping away from that framework, then you may have some work to do in establishing what the strategy is going to be for identification of the proper rules and the proper guidance. Next. If you're going to engage in substantive pre-application discussions with the NRC staff, what topics will you choose? Do you have enough methodological information to generate meaningful technical and topical reports? How much design information is available to begin educating the staff on the details of your technology? And are there new or novel aspects to your technology that make sense to put in front of the staff early? Next. An important aspect of your route planning is when you merge your regulatory and business strategy. For instance, a slow roll in regulatory space won't necessarily comport well with a rapid deployment strategy. Deployment by next year is going to be really difficult if you're floating a new design that the NRC has never seen. Regulatory assurances to your investors can be very tricky if you don't have some initial funding to do enough design for a substantive NRC engagement, whether in pre-application space or as part of an application. Next. And finally, bear in mind that flat tires happen. We have to occasionally stop for gas. We encounter detours and traffic jams and rest stops. A phrase that's generally attributed to a 19th century Prussian general is that no plan survives first contact with the enemy. Now, nuclear regulation isn't a battle, at least one hopes so, but the concept still applies. On the way to a licensed plant, you will encounter unexpected conditions. Your design will change in ways that the staff didn't anticipate. NRC project managers get changed out. Technical staff moves on to other projects. Your own funding may falter. Regulatory interpretations change, particularly the longer that you engage in your review. And interveners, well, they intervene. So you need to keep an eye on your route and shift strategies and direction when it becomes necessary. Next. So here's a representation of Kairos Power's strategy, reflecting not only the Hermes test reactor, but also our commercial design. To go from left to right, we've been in a very active pre-application engagement with a number of topical reports that have been approved or under review. The vast majority of these apply to both versions of the KPFHR design, both the Hermes test reactor and the commercial reactor. I'll talk about pre-application work a bit more in a moment, but for both the Hermes test reactor and the commercial reactor, we're planning a Part 50 construction permit and operating license. We could consume an entire conference talking about the pros and cons of Part 50 versus Part 52 licensing, but suffice it to say that we picked Part 50 to enable earlier start of construction and to avoid some of the challenges of building a first-of-a-kind plant under a combined license. Downstream of the first commercial plant, we would anticipate shifting to a Part 52 process, but we also are mindful of the significant effort that's underway to develop Part 53, which certainly could change our approach. Next slide. So here's how our own GPS entries have looked over the past couple of years. We picked the Part 50 two-step approach. Part 50 simply won't be ready in time for us. We're obviously a non-LWR, so we established the guidance framework using largely guidance from New Reg 1537 that appeared to us to be more risk-informed than New Reg 0800, and began establishing our basis for a risk-informed safety case. As I mentioned, we've been very active in pre-application engagement, and yes, we did change course a few months ago to insert a test reactor in our development cycle. Next. This is a summary of what we've been up to with the NRC during pre-application engagement in the past couple of years. We think that our pre-application engagement marks us as serious and highly credible. Over the past several years, many of those watching this will know that pre-application engagement, while optional, has been touted as one of the best ways to establish an efficient review of the license application itself. Apart from the obvious benefits of familiarizing the NRC with the design, we're also taking maximum advantage to front load our engagement with early review of substantive topical reports. We've submitted over 20 topical or technical reports or revisions. We've piloted what the NRC advertises as a no RAI approach to addressing NRC questions. Basically consists of discussing the staff's questions and incorporating changes directly into iterations of the topicals to address the questions without as formal and cumbersome of a letter generation cycle as we're all accustomed to. We've hosted multiple audits and on-site reviews, back in the day when people could travel. I will say that both Kairos and the staff have responded remarkably well to maintaining progress despite the COVID shutdown. We have final safety evaluations on several topicals with others pending, including review of 2 topicals by the ACRS. And of course, we have a number of other topicals under active review with a couple other teed up to submit later this year. Next slide. I believe that concludes my remarks, so I'll be happy to take questions now or whenever the time is right.
Well, thanks very much, Peter. There was a question from the group about New Reg 1537 and some interest in first its status, if it's interim staff guidance or a revised New Reg, and then also to reflect a little bit on your Kairos experience with the no RAI approach.
So I'll take the second one first because it's the easier one. It's been really great, and like many modernization techniques employed by not just NRC staff, not just applicants, but anywhere. Once you see something that works well, the answer is pretty obvious. So being able to have the benefit of avoiding the sort of bureaucracy of the letter and response cycles, while maintaining full public disclosure of what's going on, has been really useful. We'll get the questions, we'll have conference calls to discuss the questions and make sure that we understand them, and then we'll simply provide the staff during the calls, typically a preview of what we expect the answers to look like, build those responses directly into revisions of the topicals, and so far it's worked out really, really well. As far as 1537, There is a revision to it to address molten salt reactors, although that's molten salt, molten fuel reactors. It doesn't really apply to Kairos, but the prior versions, and I frankly don't know if that revision has been approved yet or not, but the parts 1 and 2 that are frankly pretty old, that were built around research and test reactors, is stable, has been out for quite a while. It's interesting because the commercial design that we started with, our pre-application engagement with, is not a test reactor, not a research reactor, but we felt that the structure gave us more flexibility to build the risk-informed licensing case that became our own implementation of LNP in a way that was a little easier for the staff to digest than trying to force that structure into a new Reg 0800 structure. And then when we pivoted to the Hermes test reactor, well, that's what 1537 is built for, so it was a natural evolution.
Okay. Hey, one other question, and if you have any particular insight here, and if not, we could maybe cover this with the broader panel session, but there's a question that's associated with Native American Indian tribes and how they come into play in the siting process as you evaluate individual sites. Again, I don't know if you have any background on that topic, but if not, we can move it to the panel.
I do. I've done that in a couple of prior lives, and we'll do it again with Hermes. Happily, at Hermes, a lot of that work was previously done on the Clinch River early site permit because our site is right next door. But engaging with the Native American tribes nearby is typically relatively painless. We consult with the tribes at about the same time that we consult with other regulatory agencies and reflect that consultation typically in the environmental report. I've happily never had a situation where the tribal engagement has resulted in anything that looks like pseudo intervention. But it is important, just like other community groups, to get that engagement early. You never want your local community stakeholders under whatever auspices to read first about your project in the paper or in an NRC announcement. So all the projects that I've been on, we try very early to engage with the community, including Native American tribes, as early as possible in the process.
Okay, thanks very much for your thoughts and insights. We'll move along now to our next speaker, Mark Nickel from NEI, and then again, following Mark, we'll move on to the panel session. So Mark, please take it away.
Yeah, thanks, Jim. Thanks for having me. Welcome, everyone. Let's move on to the next slide, give an introduction of myself. So I'm the Senior Director of New Reactors at the Nuclear Energy Institute. In this role, I lead a small team or group that looks at leading industry's efforts on generic issues and engagement with key stakeholders. So we represent the industry on generic issues in front of the NRC, and I'll talk about some of those generic regulatory issues. Also represent the industry in front of Congress and other policymakers, including in the states. I've been with NEI since 2011. I started my career at Duke Energy, actually worked in used fuel way back then, and had gone to Toshiba when they were looking at building new reactors at South Texas Project 3 and 4. NEI, if you're not familiar with us, we are the policy organization. We have hundreds of members, both US companies and international companies, although we do primarily focus on US policy work, and also the export of US technology to other countries. And these companies represent utilities, developers, suppliers, and service companies, as well as universities and even INL as a member. And of course, we promote the use of peaceful uses of nuclear energy with the media and the public at large. Next slide, please. Before I get to discussing where we're headed, the generic regulatory issues, and how licensing advanced reactors we expect to be more efficient and timely in the future, I wanted to provide some high-level context on the topic. And from our view as NEI, we look at advanced reactors as really being an important solution for the future. You're all familiar with the conversations around climate change and the need to reduce carbon emissions, especially important with the new administration. But it was important before that with many states and with the utilities as well. Many utilities had made commitments to reducing their carbon emissions. Many of those were to achieve zero carbon emissions by 2050 in the electricity sector. The new administration seems to want to be even more aggressive and accelerate those commitments, and then even go economy-wide to decarbonize. And that means that it would decarbonize the other 2/3 of the energy economy. The great thing about advanced reactors, not only are they zero carbon sources of energy, they're also reliable and safe, obviously, and affordable. And that's really what is needed. It has to be clean, but also affordable and reliable. And then they also offer the opportunity to produce heat directly, generate hydrogen, or otherwise be flexible to integrate with renewables. And so what we have seen and what the utilities are coming to realize as they ask themselves the question, how do we get to zero carbon emissions? They realize that if nuclear has to be part of the solution, and in fact, we need more new nuclear. The question is how much? Some would say that we need to double the amount of nuclear energy we have in the United States by, say, 2050. Some might say we need to even triple that. The question isn't, do we need a little bit or a lot? We know we need a lot. It's just how much of a lot do we need? And so that brings up the other topic, which is urgency. And the Congress recently sent a letter to the NRC and highlighted their views, and we agree with this, that it's urgent that these advanced reactors get to market so that they can be helpful to achieving the national goals. And there's a common understanding that the NRC just being part of that process to commercialization, the licensing, and the need that licensing is efficient and timely, that it's urgent that the NRC continues to improve the regulatory framework for advanced reactors. The great thing is the NRC has been doing this for over 10 years. And so it's not like the NRC is just coming to realize that advancements are needed to more modernize and better adapt to these advanced technologies. They saw this coming as well, and they've been working on many of these things for a very long time. Next slide, please. So that leads into the question of where is the construction for the path forward? And I've put it in the context of three main areas. Although I have a few example generic issues that are listed here, there are far more. NEI sent a letter to the NRC on our view of the 14 high priority activities that are needed. So some of these listed here encompass more than one, but certainly not all 14 are represented here. That would be a rather long, exhaustive list. And there are even more issues than just those 14. The other issues happen not to be the highest priority, but they're important nonetheless. So the first category is streamlining of regulatory processes, and this is really getting the NRC's licensing process to be the most efficient possible. Efficient in two ways. One, in terms of how long it takes to get through the process, that's called timeliness. The other is how many resources does it take to get through the licensing process, and that manifests itself in cost. The NRC has done a great job in improving their efficiency over the years. In the renaissance of the licensing of the larger reactors almost 2 decades ago. Timelines for review were 5 years or longer. The NRC has proved that through some efficiency improvements that they had made based on that experience, that they can now license reactors in at least 4 years. And I think there's even opportunities to do it faster than that. And what's really important is that the NRC has done it on the schedule that they advertise. So that predictability and timeliness is really important to the industry, and especially for putting together the business case for these. The performance on cost, I think there's more opportunity there. It did not see trajectories going down, but I think nonetheless a focused lens on cost and resources and efficiency in that area could achieve similar outcomes as what has been done for timeliness. Application review experience is another area with the NuScale design having been reviewed. TVA had an early site permit reviewed. Even Oklo and Kairos have some experience, even though they're still in the process. And there's other experiences that these will come up with lessons learned on how to make the process even more efficient, in addition to the things that are already going on. And so the last one here is called the Technology Inclusive Content of Application. This is a one item that's part of a longer, broader effort. It starts with a licensing modernization that the NRC has endorsed, which is a way to look more holistically at risk, to be able to streamline the content of applications. And the NRC has a companion activity going on with this they call ARCAP. And the whole idea of reducing the amount of information in the application is cross-cutting. It's not limited to this one methodology. The NRC is interested in this, and obviously the industry is. The lesson learned here is that the more information you put in the application, the more resources and time that it takes to review it. And there's been observations that in the past, sometimes more information was included than what was really needed for the staff to make a determination that the design was safe. And so the question is, if it was too much information, how do we get to the right level of information? We don't want so little information the staff can't make a decision because they don't have all the details. But we also don't want to continue to put in a lot of extraneous information that doesn't contribute to safety decision making. And so that's a delicate balance. And I'd say the work that that the NRC is putting into this, that we're engaging with, is going very well. The second category here is the resolution of key technical or policy topics. And the resolution of key technical topics and even policy topics can take a very long time. Emergency planning is the first one on the list. That has been going on for over 10 years. I don't remember how it started first, whether the NRC or industry identified it, but I do remember that along the way, NEI put together a methodology document on how you would go about a method for determining an emergency planning zone that would be appropriate to the design. Appropriate to the design means that the consequences for that design at a given radius would establish the emergency planning zone in a way that would be equivalent safety to today's emergency planning zone for the operating plants. It could be as small as the site boundary. If a design and the site could justify that their consequences were within the envelope of allowable. That criteria, by the way, is the EPA PAGS, Protective Area Acceptance Guidance. And so it has a technical basis to it. The NRC has already gone through part of the rulemaking process, and we expect the final rule to be out in the near term, and this to be finally resolved. But it does go to show that these topics can take a long time to resolve. Sorry. Physical security has been in process a little bit less than emergency planning, but the NRC has tried to accelerate that so that those timelines are aligned as best as possible. And in physical security, it's taking a more consequence-based or risk-informed, performance-based approach to physical security. The current physical security requirements the NRC have are very prescriptive in saying that you have to interdict and neutralize the threat, that you have to have a certain amount of dedicated armed responders to do that interdict and neutralize function. And what NEI had put forward several years ago was the concept of security by design, or that the fact that many of these advanced reactors, in combination with their enhanced safety features, but also with the opportunity to design security in from the very beginning, could create a plant that was designed to withstand the design basis threat and result in acceptable consequences without the need for intervention by human armed security guards. And the NRC entertained that idea. We had put together a couple of papers. The NRC initiated rulemaking, and now they have some draft language that's going to filter its way into a proposed rule that would allow that if a plant can demonstrate that they meet specific criteria there. And then finally, siting is another key issue, and this goes to enabling advanced reactors, especially smaller designs, to be located in more areas. So the current siting requirements are very prescriptive, and they essentially say that you can have no more than these number of population living within a certain zone, and a different number of population in another zone, and so forth. And so it prescribes how many people are within that zone. Well, the original intent of siting is to look at societal risks. In siting in terms of population is to look at societal risk, and it was based on large reactors that had a certain consequence profile and amount of radiological dose that they might give to those areas. And as you look at advanced reactors, the consequences could be very different and could be very much smaller than that. And so the NRC is recognizing that there is justification for a performance-based approach that would establish the acceptable societal risks and allow the designs to calculate what the consequences would be, and then from that calculate what populations would be acceptable within their different zones. And so that's currently sitting with the commission for a decision, and we support what the staff had put forward as their option 3 to proceed there. There are other issues. Those are some of the highest importance. I didn't want to go through all of them. The last category is modernizing the regulations. This takes even longer. Modernizing regulations can often take more than 10 years, just the nature of reforming the regulations. The first in this area is in environmental. There is a lot of different tentacles to environmental reviews, and so some of those go into key generic technical issues. I decided to just put environmental in one place and talk about it here. The NRC is proceeding with developing an environmental impact statement on a generic basis, meaning that it would cover a wide range of different technologies. We think it can be created in a performance-based way. The NRC seems to agree that's what they've been proposing, and it can be informed by all of the experience of issuing environmental impact statements for the operating fleet, in a way that those have found that the environmental impacts are very minimal for many reactors, and we expect this same to be true for advanced reactors. And in fact, there are environmental benefits to nuclear reactors as well. And so at the end of this process, we would look for this generic environmental impact statement, or GEIS, for advanced reactors. that would eliminate a large scope of, I would say, application-specific information and review by the NRC. So if you can do it once for a broad range of things, there are resource savings for everybody, for the applicants, for the NRC and their review, and it just really streamlines the regulatory process. The NRC is undergoing an update to Part 52, and in conjunction with that, Part 50. These are the two licensing processes we have today for advanced reactors. In the implementation of Part 52 for the Vogtle plant and the licensing of other designs and COLAs, there was a lot learned in terms of how that first of a kind Part 52 set of regulations could be modified to be more efficient and appropriate. There were things in the area of physical security and other things. I won't go into all the details. And so the NRC has issued a regulatory basis that outlines where they intend to go with this rulemaking. And many of those proposals are helpful and important. There are some that industry experience would suggest is important that were not included, and so we've encouraged the NRC to further consider those additional lessons learned. And then finally, Part 53. This is receiving a lot of attention. It was included in the Nuclear Energy Innovation and Modernization Act from Congress that told the NRC to go forth and develop a new set of regulations to license advanced reactors. And it was primarily based on the recognition that Part 50 and 52, being designed around large light water reactors, had a lot of requirements that were specific to large light water reactors. Ross had even talked about how they're dealing with that and the fact that some don't apply to their design. And so the idea is, if we're going to create Part 50, we should create Part 53 to eliminate the need for exemptions, to allow it to be more flexible for a diverse set of technologies. And so the NRC is proceeding on that path with Part 53. There's a lot to do here, and the Congress had encouraged the NRC to accelerate their efforts, and the Commission decided to do that. The rulemaking is scheduled to be finished by the end of 2024. That's record time for rulemaking. When most take 10 years, this will be about 4 years. And so the NRC is going with lightning speed on Part 53 and is working feverishly to put that rule together. And we're continuing to engage with them to provide our perspectives on how to address different topics within that. But nonetheless, it is continuing to move forward on pace. So with that, let me stop there and see if we have any questions or want to go to the panel.
Mark, let me hit on a couple of questions. There are a few others here that I'll briefly summarize and maybe suggest we defer to the panel because they touch on some themes we already covered. One in the while you're on this topic of Part 53, first recognizing that this webinar series is built around an improved understanding of Parts 50 and 52 and what currently exists, recognizing that there's a lot of interaction with industry and NRC going on currently and coming over the horizon on Part 53. You mentioned in your presentation that there's an urgency for Part 53. Could you just, I think you maybe already touched on that here just in the last minute or two, but just summarize where industry sees the urgency coming from since Part 50s and 52 already exist and are available.
Yeah, so in my mind, it's a scaling issue. So first place to start is that Part 50 and 52 can license advanced reactors, but what we all recognize is that there's a certain inefficiency from having to take exemptions or having requirements that may be, I'll just say extraneous, but are not necessary to actually ensure the safety of the public health. And so that inefficiency, when you're going through one or two applications, you hardly notice it. But we need to get to a point when I mentioned also we need to double or maybe even triple our fleet. And that could be as many as a dozen or 2 dozen reactors being constructed at any one time. And so the NRC could see 12 applications going through in a given year. And so while you're doing one application, the inefficiency you don't really notice. If you have 12 of them, you're going to notice that inefficiency. So that's the whole point of getting to Part 53. We have to get to a much more efficient regulation so that when we're licensing dozens of these, and this may not be in 5 years, this may be 10 years down the road. But when we get to that point, those inefficiencies don't trip us up.
Okay. Another question here is, in the past, various versions of advanced non-water reactors have been built and operated, some with some limited success. The question is around whether NEI or its industry partners have been doing anything or planning to do anything on educating the public around those technologies and why we're in a different era today than maybe when they were less successful in the past.
Yeah, we are trying to educate the public on these advanced technologies and how we've learned from the past so we don't repeat the past, but also how our learnings from the past give us confidence that we can build these with some confidence and also license these safely. We are actually working with other, I'll say, partner organizations, INL and GAIN being some, with the expertise on these technologies and how they operate, to get that message out. Now, NEI, we have sort of a channel into the public and media, and so we'll put out blogs and that sort of thing. I do want to highlight that organizations like GAIN are putting together a lot of information that help support that we then filter out through our channels.
Yeah, to that point, I think we're working on some updated descriptions and some updated graphics that would be available both through NEI and through the GAIN website going forward. So, hey, one other quick question, and then I'll want to move us on to the panel session. We have about an hour or so left, so I want to make sure we have time for that. There's a question here about the applicability of generic environmental impact statements. Do those cover all ranges of reactor power levels, or is that concept, I'll call it power output limited?
Yeah, so it's still being worked. In the original proposal from the NRC, they were looking at creating categories based on different power outputs. We had provided feedback that really isn't necessary, that power is really a proxy for other performance-based characteristics. And if you actually look at it, and especially if you look at it in the context of the operating reactors, there are minimal environmental benefits even for 1,000 megawatts. So we think that if you work on a performance-based type of criteria, and that might be, for example, how much heat are you putting out to a local body of water, or what are you putting into the atmosphere? Are you meeting certain clean air acts, laws? If you use those types of performance criteria, the power output really doesn't matter in most respects. And I think the NRC is receptive to that idea and has indicated that in their recent documents.
Okay. Hey, there were a couple of other questions. I'll just mention them, but I think they fit best with the panel because they relate to some of the questions that we got from some of the other presenters. One has to do with any lessons we've learned from, or the industry has learned from, implementing the licensing modernization project approach from past piloting activities, and then also some discussion or some question around how experience gained so far from the Oklo license application review is being factored into new processes and new approaches going forward. But again, because we have an Oklo person on the panel and some other insights from other industry folks, I'd suggest we maybe work to integrate those into the panel discussion.
Yeah.
So thanks very much for your time. Tom Bergman, if you'd like, I'd hand it over to you to get us started on the panel discussion. Again, as I mentioned, we've got about an hour left on the webinar. I only have about a minute's worth of wrap up at the end. So again, I'll leave it in your capable hands to steer us through the next hour. And again,
right,
for folks in the audience, you feel free to continue to send questions, and we'll work through those as best we're able. Thank you.
All right, thanks, Jim. Next slide, please. Like the others, I'm approaching 40 years of experience in the nuclear industry. The last 7 have been with NuScale. Prior to NuScale, I spent 23 years at the NRC in a wide variety of positions, and prior to the NRC, I worked at reliability engineering company AirInc Research, and I was at the Naval Nuclear Propulsion Directorate out of college. Next slide. So there were themes, I guess I would say here, that you got to pick the path that best meets your need, and that varies on technology, power rating, and the ability to use the existing regulatory framework in an efficient manner. GE Hitachi is applying lessons learned to technology development, and for both advanced LWRs and non-LWRs. Oklo has done what we call a custom, at least at the NRC, we called it a custom COLA under Part 52, and they based it directly on the regulations themselves, not the guidance that was developed largely for large light water reactors. Kairos is indicated, Part 50, construction permit plus operating license for the demonstration reactor and first plant, and then potentially Part 52, design certification plus COLA for subsequent plants, and keeping an eye on Part 53. And so building from that, before we get to the questions that have been submitted that were sort of mostly directed at specifics, listening to the dialogue here, sort of a broad question, and that is part, and this is to all the panelists, and I suggest we just go through them in the same order you presented, but is Part 52 failing, or at least has it not met maybe the promise of when it was originally conceived, now more than 30 years ago? I'll start, with NuScale. We are sticking with Part 52 for the carbon-free power project, but our next application does deviate from what was originally envisioned by Part 52. Is we're not submitting another design certification. We're going to submit a standard design approval, and that decision was based largely on the additional time it takes to get certified from getting a standard design approval. In our case, that schedule is currently 18 months, which just isn't commercially viable in today's environment. And then secondarily, on the challenges Doug mentioned that you face when you have Tier 1 information and the restrictions on the ability to change the design. Doug mentioned they're going to go, although they obtained certification for 2 designs, ABWR and ESBWR, they're proceeding, at least initially, with Part 50. Oklo is doing the custom COLA under Part 52, which has always been allowed, but again, it wasn't really what was envisioned. The Part 52 process was ESP plus DCA plus COLA. ESPs have largely were abandoned after the Renaissance, with the exception of TVA. And Kairos is again proceeding with Part 50 for the Hermes and initial commercial plant, and like GEH may do Part 52 later. So kind of, what are your thoughts on the long-term viability of Part 52, especially as it was originally envisioned? So Doug?
Well, Tom, I think you said I could go first.
Yep.
Certainly segregate the originally envisioned, and then Marcus, sort of talked about where Part 52 is trying to go today, applying the lessons learned. From a very selfish standpoint, I have 2 DCDs sitting on the shelf, paying for them on a quarterly basis. I'm now a holder of a license, which all that entails for a vendor, which, until we had the ABWR DCD, we didn't hold a license for our design. Certainly for our fuel fabrication, we did. So as we looked into it, the length of time, the amount of design that should be done before you do a DCD was very similar to what you should do before you actually put a shovel in the ground. So that was sort of a timing issue. You mentioned a little bit of that. And so that was certainly an issue. The amount of, we went through multiple revs of the ESBWR, certainly not inexpensive, certainly took longer than any of us expected. The renewal for the ABWR, we thought that would have been also very, very short and inexpensive. It's not necessarily turned out to be the case. It's certainly been a little bit more expensive than we thought to. So from originally envisioned risk-reducing build to replicate time over time, it did meet that expectation. As we look to the NRC and the industry, NEI, look to improve the process, it's possible it gets there. It's just not in the time frame that we're looking for, it seems to be. So again, a Part 50 with the customer that has very good siting relationships with the surrounding communities, where we'll go a little bit easier in that manner. The site that has fairly low risk associated with it, we see that as a path to getting constructed sooner and faster, and then using those lessons learned, and then again after maybe first, second, third unit, we certainly could see the value of things standardizing at that point and making future applications even simpler, but that's just to be determined.
Thanks, Doug. Ross?
Yeah, so to answer your first question, then to follow up with another statement you made, to put quite bluntly, I guess, the fact that Part 52 was first established in 1989 and there hasn't yet been a single operating reactor that was licensed under Part 52.
Close.
Close, but not yet, right? And hopefully they do get there, right? But ultimately there hasn't been an operating reactor licensed under Part 52, despite Part 52 intending to be a more efficient, more streamlined process. And at the same time, we're seeing, construction costs for those reactors being constructed that were licensed under Part 52, as well as application costs, being considerably higher, would certainly lead you to believe that Part 52 has not lived up to its original intent, and that there's room to move in the efficiency category to really to help with the viability and sustainability of licensing advanced reactors. So I think there's definitely room to go there. It's probably unfair to put that entirely on the Part 52 construct, but it certainly plays a role. And then with regards to Oklo's custom COLA, I think part of the reason why it made sense for us to submit a custom COLA is we're not simply a reactor designer. Oklo is both a designer as well as an owner operator, and so for us, we're not just submitting an application for design approval or design certification that would subsequently be built, owned, and operated by a utility elsewhere. We have a vested interest in both the design of the plant as well as how it's operated, and we also have a site selected for the Aurora INL COLA. And so for us, it made the most sense to submit the entire application all at once, which included our design information, our site information, as well as our operating program descriptions in the application for review all at once. And we'll continue, I think that makes sense for us, for the near future at least, to continue down that path. Simply because that is the role that we play as an owner operator. So.
Okay, Peter.
So I'm going to push back just a little bit on Part 52 not living up to its promise. I've heard a lot of criticism over the last 20 years about nobody's implementing Part 52 the way it was intended, and that's clearly true. But the rule turned out to be pretty resilient, because no matter how many different ways we tried to put the various chunks of it together, it worked. The only thing that required a change to the regulation was when we wanted to update the design certs. So, whether by sheer providence or by design, I think the rule worked pretty well. I think the reviews, the notion of bifurcating the siting review from the technology review certainly makes a lot of sense. The introduction of the concept of the reference COLA and the standard COLAs which all lives under the rule without requiring changes to the rule was remarkably more efficient, at least for the AP1000 designs. The reason that we picked Part 50 for Kairos is twofold. One, we wanted to be able to make more progress in licensing, particularly for the site, while we were continuing detailed design. Now, you could argue we could have done that with an ESP, and certainly won't debate that, but the second reason was because for where I see Part 52's Achilles heel is a first of a kind design, where the primary lesson learned, at least from the AP1000 experience, was that as we were building the DCD, it simply didn't occur to us or to the NRC staff that we were writing a construction compliance document. And the design simply wasn't far enough along to do that well. And so a different implementation of Part 52 might be possible. I don't know, but Part 50 made more sense for us, and so that's why we picked it.
And last, Mark.
Yeah, thanks, Tom. So I'm more in Peter's camp, where I'm optimistic about Part 52, and despite the challenges that we saw with Part 52 and the lessons learned that we're trying to implement from them, I think Part 52's implementation is more better than worse. And I look at it this way. So there are two main things that Part 52 is trying to achieve in my mind. The first is, if you go back to the 70s and 80s, and this is largely a result of TMI, that the licensing under Part 50 was extending the approvals of the operating license. It was requiring a lot of backfitting and modifications to the plant to be able to meet new expectations coming out of that post-TMI understanding. And so the desire was, well, let's get approval, let's get everything fixed in place and approved before we begin construction, so we don't have to rip things out as we go through construction. It's all up there. So that's why you got the combined construction and operating license, and it did that. There's very little that the AP1000 had to rip out and change. As well, we haven't gone through ITAC, but most of the ITAC at this point have been submitted and approved, and I don't expect, as we go through the final ITAC, that Southern is going to have to make any major modifications. And so it was successful in that. And not just the COLA, there was also the ESP was created, so you could get some site information out before the COLA. Now what we realized is, well, if you do an ESP and then go to a COLA, really doesn't save you any time or money. So maybe the benefit is to sort of lock in a site early on as you're trying to make some decisions about your technology choice, and there is benefit to that. And then there's the design certification, and that will help resolve some technical things before you get a COLA, again, if you have the luxury of time there. Otherwise, do what Oklo is doing and just submit it all together. And that gets to the second major benefit or reason why Part 52 was put into place, and that is for, I'll just say, mass deployment. It's much more efficient to have that single DCD and lots of COLAs referencing it and going through the process than it is to have to do review all of that design information in the DCD over and over and over again. And what if the next group of NRC staff reviewers didn't agree with the first group as NRC staff reviewers, and now you don't maintain standardization because the designs are starting to shift just based on that subjectivity in the process. So all of that has been achieved by Part 52, and it's still there. What I think people look at is they focus on some of the challenges with Part 52, and I don't disagree that they're there. I think they're being overemphasized, and that's with the change process or too much detail in the application and Tier 1. The NRC has recognized that. The NRC wants to reduce that. Part of that is in the lessons learned rulemaking. Other parts of that are in other efforts, and so the NRC wants to reduce that. I would also say, and so I expect that to be the case. And if we look at, should we have expected 100% perfect rule, Part 52 rule on the first try? Nah, probably not. So I think what we got is pretty good, and where we're going is pretty good. I will mention that there are a few things that industry really wants, and they are important. And if they're not in the Part 52 lessons learned rulemaking, it could be the Achilles heel of using it going forward. And that's specifically a Tier 1 change process that allows changes to Tier 1 prior to getting NRC approval. You would still have to go in and get approval eventually, but that way you wouldn't have to have this huge regulatory infrastructure to be able to process exigent tier 1 license amendment requests. The other is the ability to issue COLAs, even if there's a discovered design issue with the DCD. And there's some others as well. If those aren't addressed, Part 52's viability is going to be in question. And so what I look at today, I even heard it in some of the comments. The large interest in Part 50 is what it affords is that you can get in with construction permit without having to do all of the design that is required for a COLA. So you're able to go faster, and that's extremely important for these first of a kind ones. And so you know, I think both need to be viable options going forward.
Well, I'll give you a plug there, Mark. I do encourage everyone to read the industry comments on the 5052 rule. The public comment period, I believe, is closed, but you can usually submit late comments, especially if they're, hey, we agree with the industry comments that were formally made on the rule. Well, the next one I have in general, it's sort of a two-part question, but I think from your presentations, we all know the answer to the first, which is, this is with respect to Part 53. Do any of you see Part 53 as being ready to support your applications? But then the second, which I didn't hear addressed, is, so let's say you've actually licensed and even have operating plants under either Part 50 or 52. Are you seeing anything in Part 53 that would justify the cost of generating a new licensing basis under that part, or would you likely remain with your approved licensing basis under Part 50 or 52? So again, maybe I'll reverse the order this time, so Doug isn't always first on,
Okay,
on
thanks, Tom.
base. So Peter.
It's hard to imagine a scenario where it would be worth trying to retrofit to the Part 53 rulemaking. Now, it depends, right? Anything could happen, but we're trying as an industry as hard as we can to have Part 53 reflect the parts of 50 and 52 that actually work well. So if we're successful in that, then a Part 53 implementation should be sort of a more seamless implementation of the existing framework without the overhead of things like exemptions. And most of that framework forcing into the current framework is at the front end of the process. So it's hard for me to envision a Part 53 widget, if you will, that would be so attractive that it would be worth changing an existing licensing basis, unless that widget was a really seamless way to do that, right? Then you know, maybe that might make sense.
Okay, Ross.
Yeah, so I think I'll probably echo a little bit of what Peter said. Obviously, our application is already in under Part 52. We went with the Part 52 approach. Again, it would take a significant improvement in efficiency for us to then, you know, follow up our current application for the Aurora design with a Part 53 application, when we certainly can take advantage of, I think what Mark, you mentioned it, but like we'll have essentially our reference COLA established and our licensing basis established for the design, and we can take advantage of those that review effort that was performed for the Aurora INL COLA and move it forward into future or subsequent COLAs that would essentially, you know, take a large portion of that review effort that was already performed, and then it would no longer need to be performed. So from that perspective, I don't foresee us, for future Aurora designs using Part 53. The other thing I'll add is that Part 53 currently really, in its current iteration, doesn't really support the approaches that Oklo took when we submitted our application. It's a very risk-leading rule, and it relies heavily on a risk-based approach. It has been somewhat pared down a little bit with regards to its reliance upon PRA, but it still relies relatively heavily on PRA. And for our Oklo designs, you know, for Aurora, it's an extremely simple design that, you know, can more simply leverage a deterministic approach and, with a confirmatory PRA rather than kind of a risk leading approach that Part 53 is moving forward with. And then the one thing I'll add, I think, it's been said that, folks moving forward with the construction permit for a first of a kind reactor makes more sense. I think one of the things, that I tried to cover in my presentation was the performance-based licensing aspect of our design. So I mentioned the maximum credible accident portion, but also the performance-based licensing aspect, which allows us to kind of submit, a series of programmatic controls that will then validate the design assumptions that we've made, but also still submit an application earlier in the design process for review. And I think we've successfully done that. So that was kind of our approach in that performance-based licensing methodology, was to be able to do that for a first of a kind reactor.
Okay, Doug, any
Yeah,
additional?
I don't know if I have a whole lot to add. Certainly agree. It stretches my imagination if an operating plant would change its licensing basis. The only possible scenario I could see is as if I had a DCD and let's just say international cooperation became such that a Part 53 was more accepted internationally. I might see in a situation where I take my DCD, pay for the additional effort with US NRC to have a Part 53 license if it was more transportable to other countries. But that's only scenario that really comes to my mind is really possible.
So, wow, you're a perfect straight man. That was my question I was going to put to Mark, or maybe even Jim come in. Is there an active effort by the NRC on Part 53 to make it so that approval is more easily used by other regulators?
I'll take that since you mentioned my name. Let me weave into that. I just want to make a comment on the last question. So we, in organizing and representing industry on Part 53 comments, our goal is to make it so that a design that has been licensed under Part 50 or 52 could easily cross over into Part 53. What does that mean? Does it mean that you've licensed under a plant under Part 52 and now you want to license your next plant under Part 53? Or does it mean you've got a Part 52 design certification and you license COLAs under Part 53 still based off of a Part 52 design certification? Those have to be worked out. I would agree with Doug that once you're an operating plant, it doesn't make sense to really.
Yeah, I was more referring to future applications.
Yeah.
Yeah.
But there are.
Once you're operating, you're moving forward.
Yeah, but
go ahead. Sorry.
The key thing is, and this is true for Part 53 in general, in order for it to be used and useful, which is everybody's goal, is that it has to be more efficient than Part 50 and 52. If it's as efficient, there's going to be uncertainty risk there. I'm going into a rule I've never used before. It's the same efficiency. I'm better off low risk. If it's less efficient, nobody's going to use it just because it's less efficient. So not only does it have to be more efficient, but if you want to take a design that's been licensed under 50 or 52 and then license it again under Part 53, you have to overcome the effort or resources to modify the licensing basis. Now the design, the safety, they'll all be the same, but you'll have to convert from having to meet or take exemption to very specific Part 50, 52 requirements, and then not having to take those exemptions or demonstrating how you meet a performance-based requirement like the safety criteria. So there is differences, but the safety would be, and the design wouldn't have to change. So now back to your question on whether the NRC is looking at licensing approaches that would help to export. We're pushing on the NRC to do that. We've heard that there are people that would like to use, or designers that would like to use an IAEA approach, just as an example. That's not the only one. But an IAEA approach is accepted in many countries. And so if you use an IAEA approach, then you have greater assurance you don't need to make as many changes to go into other countries. You still have to meet the NRC's requirements, and part of that would be risk conforming, and so risk conforming under the NRC and IAEA might be a little bit different. So there may be a little bit of departure, but the goal nonetheless, our goal as industry, is to make it so that the export of designs are as efficient as possible. The NRC is open to that. They're not specifically creating it, but they are open if we can propose to them what such approaches might look like. They're willing to accommodate them in Part 53.
Hey, Tom and Mark, I might add another piece to that. The NRC and DOE is funding some of this activity as well within the international community, is working to describe a risk-informed approach that touches on a lot of the foundations that have been carried forward, either with LMP or going forward with Part 53. So I know, for instance, that the NRC is an active participant in the working group on the safety of advanced reactors, the WGSAR. So that's a collection of international regulators and has started this dialogue around this kind of process. I understand that the IAEA has some initiatives underway as well to expand their safety guides to encompass advanced reactors. I think the challenge is a lot of those IAEA-based approaches. They started with light water reactors, as you know, as everyone has, but they tend to be a bit, in their current form, they tend to be a bit more expert judgment based than some of the processes that have been developed more recently in US and Canada. So I think there's a lot of effort there, and I think it's recognized that US developers could significantly benefit from having a structure that's globally accepted, but probably a little ways to go to get to that place. But I think at least the dialogue is starting. So.
Okay. Let's see. For Oklo and Kairos, getting back to Jim's discussion of the earlier sessions, since obviously for Aurora you've done the siting, and for Hermes I assume you're working on it. What is your perspective on the relative risk of siting compared to the total licensing risk? You mentioned 50%. Is that about right? High, low? Peter?
I'm a licensing guy, so the answer is always it depends, right? 50% seems a little high, but it's not trivial by any means. I think, if I remember right, Doug was the one who fielded that question originally, and he talked about community engagement. There are certainly site specifics. If you don't know that you have good geologic stability, for example, that can kill a site, right? Similarly with hydrology, water usage, if you're relying on water and you're on a stream or a river that doesn't have a lot, an ample flow, that can be a big deal. It can be expensive if you have to acquire property. I've been on a couple of projects where that's been the case. I think more broadly, the environmental review, of which siting is a subset, is at least as high a risk of the safety side of the review, because if you're not reasonably convinced as a developer or an applicant, a site applicant, that you can field a safe design, well, you're not going to submit an application, right? So that's sort of self-governing. But the NEPA process is still a little bit of wild west, particularly when it comes to intervention. A lot of contentions get fielded, I won't say irrespective of merit, but they're certainly more broadly admitted than safety contentions can be. The burden that goes into the need to evaluate alternate sites, alternate technologies, the amount of work that you have to do to demonstrate that a plant that's licensed under NRC regulations doesn't have a significant environmental impact is mind-boggling, particularly compared to the environmental review that most of our electrical generation competition has to go through, which is virtually none. So the environmental review, which has in some proceedings risen to critical path, can be a huge risk, and in my view, unnecessarily so. I'm a very strong advocate for making the environmental review as painless as possible, based on the the simply undeniable fact that nuclear generation has a net positive environmental impact, and you just can't say that about most other generating technologies. So you're going to get me on my soapbox if you're not careful. So I guess I'll stop there.
Sure. Yeah. So again, I hate to, 50% is a number. I don't know what the basis behind the number was, but again, I kind of agree with Peter in the sense that it really does depend. There's so many things that go into siting and siting risk, that it certainly depends upon your location, certainly at least from an environmental perspective. One of the things we've tried to do at Oklo from our siting approach is to really bound what our design, the siting characteristics by which our design can, sustain, and then that, focuses, our review on, or the additional design characteristics on those site-specific items that aren't bounded. And I'll use the example, I think Doug brought it up during his presentation, that their design essentially is, they designed their vessel, I think, to sustain, 80% of the seismic activity, or I don't remember the exact number, but something like that, some large portion of, the contiguous US, seismic activity, to the point with which that precluded them from having to do additional design review based on a specific site seismic activity, assuming it was bounded by that overall, design seismic activity. And I think, from Oklo's perspective, we try to do the exact same thing, but on a larger scale for more than just seismic, but, for a number of characteristics where you can, bound a design by a large portion of the, the US's, siting characteristics. From an environmental perspective, that's certainly, I think, a bit more difficult to itemize in terms of the risks, right? Because there just really are so many facets of it, from the, the societal impacts and how that works, whether you need to do additional outreach. Again, that's very location dependent upon where you're planning to site the, site the reactor. There's also I think a significant increase in interagency, communications and coordination. Other agencies begin to get involved, and the extent to which that, can challenge a review. I think there's certain challenges there as well. So again, it just depends really upon a lot on the location itself, but also again on the impacts of the reactor on the environmental review is fundamentally based upon what the impact of the reactor is. As Peter mentioned, it seems that from a nuclear perspective, we seem to go through significantly more review than potential counterparts. And I'll use Aurora as an example, right? Our water usage is comparable to that of a residential household, but yet we're from a COLA perspective, right? We still have to justify that as a portion of our environmental report, that still requires an environmental impact statement from the NRC, despite the limited impact on the surrounding environment. So I think there's definitely room for improvement on the environmental side.
Interesting. So Doug, I forgot you have 2 COLs, and I think North Anna had an earthquake during the COL review, right?
They certainly did. And
so how was your siting experience, especially when that happened?
That was certainly not the most exciting part, most fulfilling part of my life when we had to go back and redo the seismic analysis. But as Ross mentioned, we haven't incorporated. In the end, it changed. I mentioned that one layer of rebar we had to add in. We had one number 18 rebar that had to be added as the seismic for the East Coast increased. Unfortunately, as Mark mentioned, sometimes we had too much detail on the DCD, or in the code and the incorporated by reference. So there you go. So it did. Not only we had to redo the seismic, we had to make a license amendment request based on that additional piece of rebar in a particular section of the reactor building. But we have incorporated that new earthquake profile. It's now adjusted into our standard profile that we apply. And so going forward, it would have been bounded, but it was not bounded by the initial design for the ESPWR.
Mark, do you have anything you want to add?
Not a whole lot. I just want to mention the timing of risk, and not so much the broader siting issues, but specifically the environmental issues. And I know talking with utility potential customers and owners of plants, they're very sensitive to the timing of risk. And so if the environmental reviews are at the operating license stage, then they're sensitive that their risk is at the end of the process. They would like to reduce risk as early as possible within the project. So to the extent that a construction permit or other vehicles can help to reduce that licensing aspect of citing environmental risks, that would be important.
Okay, and the question was directed at you, but I think the others may want to weigh in. So what are the licensing modernization project lessons learned to date from piloting efforts?
Yeah, so there were several pilots, and I don't recall all of them. I know Oklo did some piloting of the LMP process, I believe Westinghouse and others. And then there's the follow-on effort, which is TCAP. So if LMP is, I'll say it's the calculational methodology for risk, TCAP is how do you take those results and put them into an application. And there have been several piloting or I'd say tabletop exercises with those. I think they're all finished. I think GE was one of them, and some other companies have tabletop that as well. I don't have all the details of the tabletops, except I will mention that they were positive from the standpoint in that they're helping to inform the guidance and the NRC's review of the guidance that we should be submitting later this year. And so there are certainly a lot of companies that are interested in using LMP. Some companies want to use LMP in sort of an alternative approach to what's in the guidance documents. And some, say, hey, LMP is great, but we actually see some advantages in a different methodology.
So Doug, Mark mentioned you, but also you had a question related to it, but the question for you was very specific. It was explicit reliance on the LMP for safety case development to create a liability for plant vendors to guarantee the reliability measures that in the PRA itself.
Yeah, so a little bit deconstructed, there's certainly some open issues, discussions going on about how we maintain the reliability of individual components as they relate to systems, as they relate to overall LMP. So, to look at it, not the approach we're trying to take, the scene that is on the table working through is not too dissimilar from the maintenance rule. The existing facilities are going down as far as setting targets, evaluating targets. That seems to be work fairly well, so we have some confidence we'll be able to work through that. The real probably challenge part, not surprisingly, is the first of a kind components where you don't have decades of experience on a particular component. So how do you set that? Certainly, our PRA experts have a lot of experience putting margin in there, and so we believe in the end will be acceptable, but it is certainly something we're working through right now. And maybe sort of back to one of the things Mark mentioned. No, we'll mention.
Sorry, go ahead, Doug.
Real quick. For the LMP, we see a lot of value in that in our sodium fast reactors, where it is relatively new. Of course, that you can trace the history back quite a bit. But we did take a slightly different approach for our light water reactor, Vitobrax 300, based on the wealth of experience we had for defining initiating events, be able to do a fairly quick run through the PRA first. And so I think both, well, at least in the GH case, both have merit, but we certainly still see in a situation where you have a very new design or towards that spectrum of new design that LMP will continue to have value going forward.
In Ross, you similarly had a fairly specific question, but elaborate on LMP in general. But what were the key considerations in proposing an alternative approach to the LMP?
So I'll answer this. I guess I'll answer a little bit of both. So from the lessons learned perspective, we did do a pilot of the LMP early on. Some of the early lessons from the iteration of the LMP guidance at that time was that defense in depth and the application of defense in depth was heavily frequency based rather than consequence based, and that resulted in an extensive reliance on special treatment for SSCs that were not necessarily safety related, but still requiring special treatment just simply by their frequency values without consideration for consequence. And then the other piece being the the treatment of passive SSCs. And again, the initial iteration of LMP heavily, we essentially assumed complete failure of a passive SSC, which is not extremely accurate in a traditional sense. So now I'll note that both of those lessons learned in our presentation of that were incorporated into the final version of the LMP in terms of what was presented in NEI 1804, and so we're happy to see that was considered. I'll note still though that the LMP process still leads with a frequency evaluation first and the consequence second. And I think ultimately, from our perspective, consequence should lead first, since that's ultimately what the end result is, and whether there should be, changes made to a design that should be based on consequence over frequency. And the application of dense and depth still for, to scale back special treatment when you're, applying defense in depth as is currently in NEI 1804 still requires a pretty robust review from a panel and essentially a very resource intensive effort, to go back and reanalyze the design, for what defense in depth considerations should be given, and to scale that back into what really should be appropriate based on the consequence again, rather than frequency. And so we still felt that process that process in addition to just the overall risk-based measure of the LMP was too, I think it was too complicated and too burdensome for our approach. We had a very simple design. Our design could take advantage of a deterministic approach and the conservatisms that are naturally built into a deterministic approach. We see, the use of PRA similar to the original intent of the commission policy statement, which is, a complement to a deterministic approach and a means to reduce conservatism where practicable. And I think that's the way we've incorporated that into our design, as we started first with a deterministic approach to make the simplest, safest version of our design, and then use risk insights to both confirm what we've prepared, and then, as necessary to reduce conservatism when we can.
So I'll continue with you, because I think you just addressed this maybe in different fashion than the question, but isn't there a trade-off with the maximum credible, I love that word, by the way, I wish I knew what it meant, accident approach that could result in a more conservative and potentially more costly design? And do you think this would be practical approach for a larger and more complex design?
So I think similar to the way, we analyzed PRA for our simple design and the trade-offs there, and the increased analysis that we required that we felt was unnecessary based on the likely failure frequencies associated with, certain components in the overall initiating events. I think in the same way, when you're evaluating a design from a maximal credible accident approach, right, you do rely on a heavier conservatism. And so certainly, that's going to be up to any designer, as they're developing their design, whether those conservatisms work for them. Certainly you can do them. It may end up being more costly depending upon, what you put in place. And so I think the trade-offs are going to exist no matter which approach you end up taking. And ultimately it comes down to what the business interests of the designer are, and what the business case of the reactor is to determine what approach works for, for each designer.
Doug or Peter, since you have quite a bit larger designs than Aurora, any comments on taking a similar approach?
Not envisioning it right now for our designs, but I appreciate Ross's comments on it.
So we're using the MHA under 1537 for the Hermes design, since it's a non-power reactor, but we're still backing it up with I'll call it a pseudo LMP approach for a smaller reactor, and we're doing that in part to sort of exercise that LMP muscle for a commercial design. And so if for a test reactor we felt compelled to go do LMP, it would just be a matter of excuse me, building the results from that into the Hermes application. I think what Ross says is right. Is a function of complexity. You got to do enough sort of show your math in the background to convince yourself that your MCA or your MHA is in fact bounding. And an LMP type tool is one way to do that. I will comment on the previous question that I think the risk of, I forget the exact way the question was phrased, but reliability targets essentially becoming part of your licensing basis. I think that risk is real, and I hope that doesn't happen. There may be SSEs that you're sufficiently reliant on, or your data are thin enough, or the consequences are significant enough that you would need that as part of your licensing basis for that SSE. But if that becomes sort of the price of LMP, then LMP execution will have failed, I think. That's one of the things that we've been trying to drive the Part 53 rule away from, is the notion of building, quote, the PRA into the license application, and thereby making all of its component parts, dragging it into the licensing basis. We think that the way it's been implemented in Part 52 space, where what's important is not the number that comes out of the PRA, but the risk insights that come out of it, is really the important part. So sorry for backtracking on the questions. But.
On your last comment, it'll be interesting to see how risk-informed is implemented, especially if you do get to those are now rigid licensing requirements, because we're seeing that a little bit on the EPZ. Topical is, what if you didn't put enough uncertainty around equipment performance such that you later, when you have equipment performance, say the worst case, you no longer meet the criteria for a site boundary. You would assume you can design your way out of it or program your way out of it, but it does raise this risk of, if everything was wrong, where am I at? So the discussion of uncertainties around equipment performance has been a focus area on at least that aspect. We did maximum hypothetical accident like you did. We didn't believe we had any credible events that led to core damage, which of course now you have nothing, to work with. So we did end up reaching agreement with the NRC on a maximum hypothetical accident, which is a stylized event. You can't really say how you get to it, just to create a source term. Again, principally for use in EPZ, but not only there. So it's the risk-informed approach is I think a struggle for everybody, but it is still the right path, I think, long-term to go down.
Hey, Tom, this is Jim. Just real quickly, I just want to give you all a time check. We got about 20 minutes left. So again, I know you have a lot of topics you'd like to cover. So just again, clock check.
We've gotten to most of the questions. I'm scanning through them now to make sure I didn't, I'm not missing any. I mean, we may not have directly answered each question.
Tom, while you're looking at that, let me add a little bit to the maximum credible accident response. So specifically in terms of whether larger reactors, it makes sense for them. I would say, based on everything I'm hearing, and a lot of this is in the context of Part 53, the types of designs that are interested in maximum credible accident tend to be the micro reactors, the very small. And I think the reason is because they're much simpler and it's easier to come up with a maximum credible accident. There just aren't as many event types or sequences to sort of, really need a systematic, a more systematic approach to coming up with them. Now, a lot of people are still interested in using a PRA or a qualitative risk tool to do a systematic confirmatory check that, hey, the maximum credible accidents there is appropriate. The other reason, I think, is because it's not so much that the micro reactor necessarily has to add in a whole bunch of excess conservatism. It's the fact that the consequences are so low that excess conservatism's already there. And whether you do an MCA or do something else, the design is going to be exactly the same. So it's more taking credit for the conservatism that naturally occurs there by the MCA. And it's also the fact, I think maybe this is more the simplicity of it, to come up with an MCA, it's I'll just say a more credible accident. You're not having to look at the complexity of it, saying I can't figure out what the MCA is, so the MCA is a meteor hitting my plant. You can actually come up with something that's more realistic, like, well, loss of coolant, and everyone can look at it and agree, yeah, that's a maximum credible accident. So just offered that.
No, that's good. And I can see it. Yeah, well, if the design gets simple enough that you can, it doesn't appear scalable to our size, certainly, but or maybe some others, just because you can come up with, hopefully not the meteor striking the plant kind of event, but a lot of failures, right? You can take a lot of failures can get you there. Another question for you, Mark. And it is, how is the rush with Part 53, because you noted, it's light speed, is that compromising its usability and effectiveness?
At this point, it's undetermined. The acceleration of the Part 53 rule, I think, is accelerate. Well, it's making it faster to come up with something more concrete. And what we find with any rule is there's a lot of discussion that the NRC needs to have with stakeholders to meld in everybody's thinking. I would say it makes for maybe a little bit more sensitivity to what things are. There's a little bit more concern that the first proposal is ending up going to be the last proposal. Perhaps even a little bit of reluctance to explore new ideas, and so those two sort of go together. So I would say, while we think the timeline is appropriate and absolutely achievable, we need to work extra hard to make sure that we get there with a successful rule that's used and useful. So yeah, it does take a lot more effort.
I guess I'd offer sort of a follow-up on that, is if getting a better rule took longer, what would be an industry's position? Not years longer, but an extra year.
Yeah, so we don't want to let perfect be the enemy of the good, and there really is a lot of importance to 2024. If it were a matter of the rule is just not going to be used and useful, then absolutely the 2024 should be reconsidered. If it's a matter of it's a more efficient rule and it's better, and to do anything more is going to take 2-3 years, then we're likely better off just to get this on the books so it can be used, and then look at improving it going forward. And then there's everything in between. I think it's really too early to tell where we may end up on this, but at the end of the year, I think we'll have a better idea.
Okay, question for Doug. Can you discuss your experience or reactions from the NRC following the IAEA defense in depth approach versus the traditional single failure criterion?
It's the overall reaction to the NRC has been positive. Now it is different, which causes, well, let me start again. NRC, obviously large organization. The people we tend to talk to, project manager on through NRR, have been receptive to it. One of the things we are considering to more lock it down and make sure that all the reviewers would have a common understanding, or at least as common as you can for individuals, humans, is to perhaps do a licensed and topical report about it. I mentioned, from a single failure standpoint, in my presentation, I mentioned our attractiveness for using IAEA to make it more portable throughout the world. We can take IAEA and map it back to US NRC version, the NRC bases, doing the opposite direction, which we tried with the ESBWR. You might even effectively tried with the ABWR, where we took the licensed ABWR in the US, Japan, Taiwan, and then did the HDNA, did the Hitachi G Nuclear, did the General Design Assessment in UK, and it was actually, we retrofitted, but in part of that process, when we're retrofitting the defense in depth that IAEA recommends or proposes, is it really became obvious to us when we start our next design, happen to be the BWRX 300, that real clarity, the systematic approach to putting things in defense lines allows us a lot easier application for things such as common cause failure. You know, the BWRX 300, the ESBWR passive plants, so we don't have quite as many reliances on our highest safety grade, safety related, or safety class 1 equipment for support systems, but untangling that web of support systems without doing a defense in depth proves difficult. We even had some of that in the ESBWR. One of the other things we really like about it is, as you go through the systematic approach, you really develop this fault tree that goes along with it. And so you can easily answer the question transparently, why is this what it is? Why is this this safety class? Why is it has this attribute? With the fault trees, you can very easily march along, understand which systems and components are needed when, and how they're utilized, as opposed to, well, you know, we took the last 10 years of operations and we applied that to it, and we took the 15 years before that, and, you know, just continues to build and build, and you can't really go back and pull the thread on why is your safety case the way it is in individual situations. You know, it's still safe, but when you say, why is this particular component safety class 1 or safety related, oftentimes it's gotten lost in just the various different ways that we analyze things. And so with the systematic approach the IEA defense in depth approach has, the fault tree that goes along with it, fault schedule, if you will, goes along with it, it makes it a lot more tractable and easier to use in our opinion.
And you probably know we support, of course, that approach as a way to do defense in depth.
Yep.
Peter, what's your view as another larger plant of the IAEA SSR 21, if I remember right, for defense in depth?
Unfortunately, I'm not more than a question deep on that topic, so I'd have to defer to Doug's assessment.
Okay. Just looking for another question here. So, Ross, this one's directed to you. During your pre-application engagement process, how long did it take for NRC to accept your regulatory engagement plan? And then really a separate question, and establish the review schedule. So look at that as two questions. And Peter, you may have an answer to the first one as well.
So
go ahead.
So we didn't spend a significant amount of time in pre-application. We did present some topics early, things that we wanted to coordinate on, but ultimately we felt confident that the NRC was prepared to review an application for a first of a kind reactor, and so we submitted with that understanding, and so it our process really mostly started. We did several years of pre-application, but the extent to which that involved was very minimal in terms of topical reports and whatnot. So I think we have done the bulk majority of our interaction with the NRC in application space itself. So we had our application submitted in March of 2020. It was subsequently accepted in June of 2020. We actually don't have a review schedule, interestingly enough. So the process with which the NRC has kind of approached this is a step 1, step 2 approach. So step 1 is to understand the methodologies that we utilized, specifically with regards to the maximum credible accident, the classification of SSCs, and the role of quality assurance, in our application. We had some substantive engagements with the NRC early on to help kind of articulate that. And what we felt was the most worthwhile and productive approach to move forward on understanding those methodologies was to separate them out from the application, to first have an agreement on what those methodologies are, how they may be used, what they can and cannot do, before then discussing how they are applied to the Aurora design themselves. And that's part of why we separated those methodologies from the application into separate topicals, which we plan to submit, and then we'll proceed from there.
Peter, does Kairos have a formal regulatory engagement plan?
Yeah, we do, but it's not one of the documents that typically receives NRC approval per se. It's really submitted for information, and if there's something about it they don't like, they'll certainly tell you that. But most of what was in our regulatory engagement plan was content we had already discussed with him previously, like, anticipated review schedules, streamlining the RAI approach, things like that. We've had pretty good success on aggressive review schedules for our topicals. Like Oklo, we put a lot of methodological content into the topicals, so it didn't sort of kludge up the application review itself. And the only difference is we've done ours in advance of the application. But the reg engagement plan wasn't really submitted for approval anyway. So the acceptance of it wasn't something that we tracked, but it wasn't particularly controversial either. There wasn't a lot in there that they hadn't already seen.
Doug, do you have a reg engagement plan?
We have discussions, for the BWRX 300, it's really focused around the licensing topical reports we have now, so not a formal regulatory engagement. As we look at some of our potential customers and the applications they submit in the future, there's certainly engagement plans that they're developing that we're supporting on. But I would, echo what Ross and Peter both said, that from a historical basis, NRC is certainly moving faster now. They're making aggressive schedules and they're keeping them, or compared to history, aggressive schedules and keeping them. So we are certainly appreciative of that, and the NRCs are tending to move in a more forward-focused, time-based, schedule-based than we have seen in the past. That's good things, we think.
Excuse me, Tom, we've got maybe about 4 or 5 minutes left for panel discussion.
This is the last question. I'll give the NRC credit there too. I've never seen them work so hard to maintain schedule as they did on our review. It's certainly a different environment than when I was working there. So that was good to see. And our experience on the regulatory engagement plan is similar to Peter's. We didn't submit it for approval, but they do comment on it, and it's for others planning to do it. We do update it periodically because circumstances change. Our pre-engagement for this application is really heavily focused on the review process and application content, optimizing the content, not so much on the technology since they just completed a review of it. So it'll vary based, I think, on where you're at. If you're a first of a kind design they know nothing about, I think your pre-application will be a lot more education on the design and the safety case, which is what we did for the DCA. So everybody's will be different, but I do think the framework that NEI put out, I can't recall the document number, but it's a pretty good framework for developing a regulatory engagement plan. So any final comment? Apologize for those who didn't get their question answered. I think we try to answer. Jim, I'll need you to weigh in. Do we try to answer them in writing after the fact? But any final comments from the panelists?
Or we can work to respond to the ones we didn't get to. There was one that was kind of near the end of the list here. I wanted to just mention as an observation. I think it's a good question. We won't solve it today, of course, but I think, as you all may know, in the earlier days, back in the 70s, NRC's reviews were provided at the cost of the taxpayer, not the cost of the applicant. So they were essentially free for the fleet. So the bulk of the operating fleet out there today got their initial review without having to pay by the hour when the NRC was reviewing their application. That the NRC's current fee recovery schedule went into play. I don't remember the specific year, but it was around the time of the Reagan administration, roughly. So the question out there is, with the push in U.S. Either policy or at least ambition to decarbonize, maybe there's an opportunity to rethink that fee recovery construct for, at the congressional level, and maybe sort out a structure that looks something more like the 70s when the industry was rapidly expanding back then as well. So again, I'll just throw that out there, not for us to respond to, but just I thought it was a very good and a very interesting question.
Yeah, Jim, I'll point out that Nuclear Innovation Alliance just issued a report that made that exact recommendation. We had a panel session on it, I don't know, a week or two ago. And it makes for good reading. It makes a pretty compelling argument in my view.
Oh, good. Well, hey, again, I'm sorry.
I was just going to chime in and echo what Peter said, recognizing that report is out there and they kind of highlight, some alternative licensing or like fee schedule approaches that could be considered, if there are to be policy changes. I think we're generally supportive of, that maybe fee recovery and the way the NRC charges their fees should be revisited in light of the fact that there is a huge, large global and nationwide effort to decarbonize, and nuclear is clearly a strong, option to support that decarbonization.
Sure. I appreciate that. I wasn't aware of the report, so I think that'll be good for participants to be aware of. So thanks very much. Again, I was going to go to just a few closing slides. Before I do that, I wanted to first thank all of the panelists for taking time out of your day jobs, both to put your presentations together and then to support us in the discussion this afternoon. I think it was very insightful for a lot of folks kind of across the landscape within the stakeholder community. The only thing I have really in closing is a pointer to, Holly, if you could go to the next slide. Again, I just wanted to thank everyone for their participation, not only today, but if you were either a presenter or a participant in one of the first 3 webinars in this series. Again, our overall goal was to build familiarity with the current structure, talk through some of the issues and uncertainties, and maybe less obvious parts of the process that should be considered as you're on your road to a timely deployment. We really do appreciate the insights and inputs from the industry panel members today. And again, this wraps up the 4th of our planned 4 webinars in this series. If you could go on to the next slide. I wanted to mention that if you have any inputs or additional insights, please email them to that GAIN events address that's there in the first group of sub-bullets. I'll also mention, as I did at the beginning, that all of the presentation material as well as the video recordings, both from today and from the first 3 sessions, can all be accessed on that GAIN website, the GAINinl.gov. And I'll also mention that within the GAIN community, we can assist where needed in either answering questions about the regulatory process or helping to facilitate engagement with NRC specifically on individual questions or comments. If you're having any challenges in sorting out, how to get to that information or how to make the right points of contact come to fruition there. So I wanted to make sure you knew that those resources are available to you. And with that, I'll bring today's session to a close. Again, I thank very much all of the presenters, the folks who are working in the background, both to put the webinar series together and to generate and portray all of the slides. And again, we'll call the session closed for today, and thank you very much for your participation.